Hello students, today let us understand definite integrals. Definite integrals, nothing but integrals with limits, starting limit and end limit. So let us go to the chapter. So let us see applying the limits. Let's say this is a curve. It's a straight line, y is equal to x. So it's going to the origin. This is y is equal to x. Now I want integral x dx from limits a to b. So what it is going to show me? Let us take a small strip here. Small strip, this is x dash. The value on the y is y and y dash. Because this y is equal to x, so y is equal to x and y dash is x dash. So what is the area of this small strip? Length into width. So x dash minus x into height. Height is we are taking average height. What is average height? Y plus y dash by 2. This is the average height. It means y is y x. The equation is y is x for this line. So x dash plus x by 2 into x dash minus x. So this is x dash square minus x square. So like that, we take infinite number of strips from A to B. So let us say first one is x1. x1 square minus a square by 2. This is the first strip. Second strip is x2 square minus x1 square by 2. Like that, what is the last strip? B square minus xn square by 2. So this is the, I have converted this area into very infinitely number of small areas. So when we add this, so x1 square will cancel. This is plus, this is minus. Similarly, x2 square minus x2 square will come get cancelled. Like that. What is left out after adding? B square minus a square by 2. So this is the area under this line between limits a and b. Let us see cross check the area. We know what is the rectangle area? A into b minus a. And what is the triangle area? B minus a into b minus a. Half base into height. Half b minus a into b minus a. When we add these two, I'll get b square minus a square by 2. The same as this. Okay, this is the area of this figure. Now, if you see simple integration, integral x dx. Y is what? Y is equal to x. So integral x dx is x square by 2. When apply a to b limits, b square minus a square by 2. Same. So whatever curve, since it is a simple curve, if there is a parabola, if there is a hyperbola, any curve, between the limits, if I do integration and submit my limits, I am getting area under the curve. Okay. So this is the basic concept of using the limits. I can find out area under the curve, I can find out volume under the curve. All the things can be found in the limits. Now let us see. So this is basic differentiation. What is the differentiation? In differentiation, we are finding slope of the curve at that point. Suppose this is the curve given. So this is a slope at this point. If I take a small x dx, you have a small dy. So this is a y2 minus y1, this is x2 minus x1. dy by dx, as dx tends to 0, dy by dx, as dx tends to 0, gives me the slope of this. So what is tan theta? Tan theta is y by x. So dy by dx is tan theta, that is, as dx tends to 0, this will become a differentiation. But integration, we are getting entire area between the limits. From A to B, there is the area between the limits. See, so dy by dx is f of x plus h. That means this point. This is x. This is x plus h. So this is f of x which y1 minus f of x. So this is x. So this point is f of x. So f of x plus h minus f of x is y1 minus y2 or y2 minus y1. So this dy, this is nothing but dy by divided by x plus h minus x. So that means this h divided by h, this difference. So we are getting dy by dx is defined as f of x plus h minus f of x by x plus h minus x as h tends to 0. The differentiation. What is integration? Here we do this integration. You see here, area under the curve, integral f dx. Now this area has been divided into several number of components. You see the vertical lines. 0 to 1 is divided into n components. Similarly, 1 to 2, another n. 2 to 3, another n. Like that, up to p, we have total np components here. We have taken np readings. So I is from 1 to np. I is from 1 to np. So each y I am adding. Each y I am adding f of I by n. F of I by n. That means suppose I is 1. So this is 1 by n, 2 by n, 3 by n, 4 by n. Like that, it comes to 1, it is n by n. Here it is n by n. Like that, here it is 2n by n. F of 2n by n is, this is the point. This is the y point. F of 2n by n. Like that, f of 3n by n. Like that, f of np by n. So finally, I am getting 0 to np f of np by. I am adding all y's. I am adding all y's divided by n. So what I am getting here, when I am dividing by n, I am finally getting p into sigma y. P into, because this is np into y, so n getting cancelled, p into y. P into y nothing but area. Suppose if it is equal, if it is a rectangle, then becomes p into y, p np into y by n. N get cancelled, p into y is my area, length into width. So if it is a curve, I am adding all y's, individual y's up to np times divided by n. So I am getting p into y, average of p into y, that is nothing but the area. So this n is infinite. N is infinite. Here 0 to 1 is divided into infinite parts, as if h is 0. As if h is 0. When 1 by 0 is infinity. So this is my integration. So I am adding, instead of areas, I am adding lengths here. Length, 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 length. Length into p is my length into np by n is my integration process. This is nothing but, in simply we say it is integral f dx limits 0 to p. Here it is 0 to p. In sigma, it is 1 to np f of I by n, 1 by n. So these are the two understanding of integration between the limits. Okay. Let us say. Example is there. X square plus 1 dx. This line shows x square plus 1 dx. When x is 0, y is 1. When x is 2, y is equal to 5. So I want between limits 0 to 2. So if I do integration, so this is x cubed by 3. This is integral x. X cubed by 3. So what is x cubed by 3? 2 cubed by 3. 2 cubed by 3 plus x is 2 minus 0. This is 0 by 3, 0, 0. So if I do through integration process, I am getting 14 by 3 square units. Let us do 1 by n process. 1 by n sigma f of I by n. I is 1 to, because this is 2 np. n p is 2, so 2n. So one division is divided into n times. Second division is also divided into n times, where n tends to infinity. So now I am adding this. Sigma a is sigma x square dx. So 1 by n into 1 by n whole square plus 2 by n whole square, like that 2n by n whole square. In place of x, I am putting I by x. This is I by n, f of I by n. In place of x, I am putting I by n. I is 1 to 2 here. So first x is 1 by n, second x is 2 by n, second is 3 by n, 4 by n, like that here n by n. Then it comes here 2n by n. X square, so I put whole square. So each y I am adding. So if I do is 1 by n, if I take out n square outside, so 1 square plus 2 square up to 2n square. This we know, n into n plus 1 into 2n plus 1 by 6. So here it is 2n terms, so 2n into 2n plus 1 into 2 into 2n plus 1 by 6 by 1 by n cubed. So if I take out n into n into n cubed I am taking outside. So this becomes 2 into 2 plus 1 by n into 4 plus 2 by n. So now we substitute n is infinity. When I substitute infinity, this is 0 and this is also 0. So what I am getting is 2 into 2 into 4, 2 into 2 into 4 by 6. By 6 is there? By 6. So that is 8 by 3. Similarly, integral dx is equal to 1 by n into, here it is 1 by n, again 1 by n, 2 by n, 3 by n, 4 by n, like that 2n by n. So 1 by n into 1 plus 2n by n. And taking out, so this is first 2n terms, 2n into 2n plus 1 by 2, 2n into 2n plus 1 by 2. So this becomes 2n by n. So 1 plus 1 plus 1, 2n times. It's not 1 plus 2 plus 3 like that. Here it is integral dx. There is not x dx. It is dx. So I is 1. I is 1. So everywhere we get 1 by n, 1 by n, 1 by n, 1 by n, like that 2n times we will get. If it is x is there, suppose integral x dx, then I will get 1 by n, 2 by n, 3 by n, like that 2n by n. 2n by n. So here we are not doing a integration. X square by 2, this is x cubed by 3. We are not doing. We are applying this sigma process. Sigma process. Here also I am applying sigma process. This is sigma process. So if I add each y, so 2n times. So the 1, 1, 1, 2n into by n, that is 2. So if I add these two areas, 8 by 3 plus 2 is 14 by 3. It is same as my earlier things. So let us see another example. Okay. Integral x plus e to the power of 2x dx, limit 0 to 4. So this we know integration process, x square by 2 is e to the power of 2x by 2. We know this integration process, but we want to understand from the fundamental addition. We want to understand make our concept clear. What is this integration doing fundamentally? So we know each one is divided into n times. 1 to 2 is divided into n times. 2 to 3 here up to 2 only. So these two are terms 2n times. So like that here integral x is 0 to 4. So this is divided into 4n times. This is divided into 4n times. I is 1 to 4n sigma. So sigma x dx. Sigma f of I by n, 1 by n, sigma f of I by n, I is 1 to 4. Similarly, second one, e to the power of 2x. 1 by n, same thing I am writing, 1 by n, x dx, x in place of x, I am putting I by n. So 1 by n, in place of I I am starting from 1 to 4n. 1 by n plus 2 by n plus 4n by n. So I am taking n outside, 1 by n square. So this becomes first 4n terms addition, 4n into 4n plus 1 by 2, 4n into 4n plus 1 by 2 by n square. So if I take n out here, 4 plus 1 by n. So if I put n infinity, this becomes 0. So 4 into 4 by 2 is 2, 2 into 4, 8. So the first term a is 8. What is the second term? Integral e to the power of 2x dx. Same I am applying this. So 1 by n into e to the power of 2 into 1 by n, 2 into 2 by n, 2 into 3 by n, like the 2 into 4n by n. So I am adding all the y's here. All the y's I am adding here. So now I have to simplify this addition. So what I am taking out 1 by n, I am taking out already there e to the power of 2n by n, e to the power of 2n by e to the power of 2 by n we are taking out. E to the power of 2 by n we are taking out. So what is this become? E to the power of 2 by n is taken, this becomes 1 plus, when e to the power of 2 by n is taken, 2 into 1 by n is left. Because out of which this can be written as 2 into 1 plus 1 by n. So when I take up 2, totally is e to the power of 4n. So when I take up 2 by n, so difference is 2 by n. This is 6n, e to the power of 6n, 6 by n. So when I take up 2, it becomes 4n. 2 into 2, 4. Like that, 2 into 4n minus 1n. So 2 into 1, 2 by n, this is taken out. So 1 by n, e to the power of 2 by n, when I take out 1 plus e to the power of 2 by n plus e to the power of 4 by n plus e to the power of 2 into 4n minus 1 by n. So this is a geometric progression. What is the geometric progression formula? R to the power of 4n minus 1 by r minus 1. Geometric formula? R to the power of n minus 1 by r minus 1. Here r is what? R is e to the power of 2 by n. This is common. E to the power of 2 by n is common. E to the power of 2 by n is common. So this is geometric progression sum formula. So when I simplify it, e to the power of 2 by n, this becomes what? E to the power of 2 by n, or to the power of 4 by n, or to the power of n minus 1. Or the last one is 4n minus 1. So what I am getting? 4 into 2, 8n minus 1. E to the top one is e to the power of 8 minus 1 by e to the power of 2 by n minus 1. Here, this 1 by n has come here as 1 by n. In place of that, I am putting 2 by 2n. 2 by 2 also is added. Why this 2 by 2 by n is being added? Because e to the power of 2 by n minus 1 by 2 by n, e to the power of x minus 1 by x has limit of x tends to infinity is 1. This is our standard limiting function. To convert the denominator into a standard limiting function, I am putting e to the power of 2 by n minus 1 by 2 by n. By 2 by n. Because finally 2 by n means this is under division. By 2, there is a 2 by 2 given. By n means we will come to this n is taken, this 1 by n is taken as here. So this entire function becomes 1. And what is left out? E to the power of 2 by n into e to the power of 8 minus 1 by 2 is left out. By 2 is left out. So here, if I put n 0, so this is e to the power of 0. If I put n infinity, this e to the power of 0 is 1. So this is nothing but e to the power of 8 minus 1 by 2 is the answer. So what is the total answer? A plus b. A is 8. This is e to the power of 8 minus 1. So I am getting e to the power of 8 plus 15 by 2. Let us do with direct integration. In place of x plus x, we get x square by 2 plus e to the power of 2x by 2 you substitute the limit of 0 to 4. So this is 4 square by 2. 4 square by 2 minus 0 plus e to the power of 8 by 2 minus e to the power of 0 is 1 by 2. So when I simplify it, this one I'm getting e to the power of 8 plus 15 by 2, same as this. So this is my direct integration process. This is my fundamentals of integration process. Okay, we should have knowledge of this. We of course will be practicing, but this knowledge we should have. Dividing by n and adding np times. Adding np times. So n get cancelled. P into y is my total area. So we should be able to understand. So this is the limiting function we should understand. E to the power of x minus 1 by x as x tends to infinity is 1. This is my limiting function. So the bottom one will convert it to 1. That is why we have put 2 by 2 here to make this to 1. It is 2 by n, so I should have in the division 2 by n. If it is x 2, I should have 2. If it is 1 by n, I should have 1 by n. Like that. Accordingly, we have to adjust the other factors. So then we go to next example. Let us see by direct integration, simple for us. Let us see integral dx by a square plus x square, limits 0 to a. We know this is tan inverse x by a, 1 by a, tan inverse x by a. So I am putting 0 to a. What I am tan inverse 1 is pi by 4 and tan inverse 0 is 0. So this is pi by 4 a, 1 by a into, so pi by 4 a is the area under this between 0 to a. Let us see another example. Dx root of 4 minus x square, limits 0 to 2. This is in the form of square root of a square minus x square dx. So we know x by 2 square root of a square minus x square plus a square by 2 into sine inverse x by a. You know this formula we have done earlier in integration. This formula we have to by heart because many times this comes. Sine inverse comes many times in the answer in this chapter. So let us first by heart this formula. X by 2 square root. How we got x by 2? So first I do by integration by UV method. So 1 into root of square. When I do integration of 1, I get x. So x square root of 4 a square minus x square. So by 2 comes because when I differentiate it, 1a will come here. This will become 2a. Minus a will come. This goes to here 2a. So the 2 will come into the denominator. So x by 2 square root of a square minus x square plus a square by 2 sine inverse x by a is to be by heart. So when I substitute this and substituting the limits 0 to 2, I am getting 2 into pi by 2 minus 0, that is pi. Here I have done this formula. See here, x root square root of x square minus square minus integral. This is integral x. I have to differentiate it. 1 by 2 root a square minus x square into minus 2x. So this becomes minus into minus plus because a square minus x square, there is a minus here. So this is plus x square by a square minus x square. Here I can write x square as a square minus x square plus a square. A square minus x square minus a square. So when I do this integral, this becomes minus of a, same is a square minus x square, root here a square minus square. When I do division, root a square minus x square is left out here, nothing but a, plus a square root by square root of a square minus x square. This is sine inverse x by a. So we got x by 2. This is minus a goes to a plus 2a, it will become. So x by 2 square root of a square minus x square plus a square by 2 sine inverse x by a. This whole is for the purpose of revising this formula because many times this formula comes up. Okay. So let us continue definite integrals. So far we have studied how to do integrals from fundamentals. Sigma 1 by n f of I by n, I is 1 to np. This is nothing but sigma integral fx dx from limits a to p. So this we have understood. Now we are going to understand the properties of definite integrals. Okay. Let us go to properties of definite integrals. Let us see the first property. Integral p to p f of a dA is 0. What do you mean by p to p f of a dA? Suppose, let us say p is a to a f of a dA. What is the area? A to a f of a dA? Y f of a into width. What is width here? Width is 0. A to a means a minus a is 0. So here the area is 0. So between the same limits, the area is, it can be C to C, it can be B to B, it can be anything. So the width in the X direction is 0. So Y into 0 is 0. So this is the fundamental. What is the second rule? Integral P to Q f of a dA is equal to integral P to Q f of t dt. So suppose this is f of a. In place of a, I put if a is t. If a is t, then what becomes? This is f of t. So dA is dt. So nothing is going to change. dA is becoming dt. F of a being f of t. Suppose x square. This is, let us say, this is x square. This portion is x square. Then if I put x is b, this is b square. This is y square. This is z square. So f of x square dx is equal to f of y square dy equal to f of z square dz. Because I am only simply changing the variable. What we are changing here? We are only changing in place of x. In place of a, I am putting t. I am only changing the same variable. It is not minus a. It is not a square plus 2. Nothing like that. It is a. It is t. The variable is changed. So they are same. They are same. So y-axis we are changing. F of a. X-axis is a here. F of x or f of a. Now x-axis I am putting as t. In place of x, a, I am putting t. So these are same. Integral f of a dA is integral f of t dt. Let us understand this. And integral, this is f of x dx. In place of x, I put t. Then what happens here? A square plus t square. A square plus t square. A is t, so dx is dt. This becomes dt. So when x a is and x is t, the limits also do not change. When x is 0, t is 0. When x is a, t is a. So 0 to a dt by a square plus t square. So this is nothing but 1 by a tan inverse t by a. Limits 0 to a. When I substitute these things, I will get pi by 4 here. It is independent of my x. It is independent of my t. So when I use x or when I use t, when I use y, it's all same. Integral f of t dt, f of a dA, f of x dx, all are same within the same limits. So the variable can be represented as x, can be represented as t, can be represented as y. So the answer will be same. This is the meaning of this formula. Okay, go to the formula 2. P to Q f of a dA is minus of Q to P f of a dA. What does this mean? We know this is, suppose we'll see the proofs in the next slide. Look, we'll go to the proofs. So what is P to Q? What is P to Q f of a dA is f dash q minus f dash p. Suppose f dash is integration of f of a dA. So this is f dash q minus f dash p. Suppose I take minus out, It is f dash p minus f dash q. It's nothing but minus of q to p f of a dA. So in place of f of p minus f of a q, f of q minus f of p, I'm putting f of p minus f of q. So I put a minus sign outside. The limits will be upside down. Simple mathematical addition. But if you see here, what does it indicate? So P to Q, let us say this is minus A to B. This is the area I am counting, A to B. So when I am counting from B to A, the X is minus, here X is plus. So Y into X is the plus area. From B to A, X is minus. So minus X into Y is minus the area. So that's why I put minus on that. So it is all same. A to B you count or B to A you count, the area will remain same. This is the total area covered by the curve from B to A or A to B. But only thing is here X is minus. So X into Y is minus of the area. So minus of the area I'll put minus here to convert into plus sign. Okay, this is the physical meaning, that is a mathematical application. Let us see the property 3. F of integral P to Q f of a dA can be represented as two parts. Suppose this one, integral A to B. So it can be written as integral A to C plus integral C to B. I am totally adding the area. In place of adding entire area from this, suppose if it is this is one curve up to this point, there is another curve here this point. In that case, I can add it in two parts, A to C plus C to B. Because it's a continuous. There is no gap here. After C, there is no gap here. This is a continuous curve. So I can add here A to C plus C to B. It is equal to A to B is a total area. Associative property. Okay. Next. Integral here. This is important property. Integral P to Q f of a dA is equal to integral P to Q P plus Q minus a dA. Both are same. This is also same. Integral 0 to P f of a dA is equal to 0 to P f of P minus a dA. In place of here P, here it is 0. In place of Q, here it is P. So here I put P plus Q minus a. Here 0 plus P minus a is nothing but P minus a. Both properties are actually same. So what this property says, you add the limits and replace a with sum of the limits minus a dA, it remains the same. Let us see its proof. This is the proof. Let us put a t, another variable, as p plus q minus a. And what is a is becoming? A is becoming p plus q minus t. So what is dA? dA is p plus q are constant terms. The limits are constant terms. So this is minus dt. Minus dt. So when a, what are the limits here? A is p and a is q. When a is p, if I substitute a as p, then what is t becoming? T becoming q. When I am substituting a as q, t becoming t. So now, when we rewrite this one, integral p to q f of a dA can be written as, in place of a, I am putting p plus q minus t, because a is being defined as p plus q minus t. F of p plus q minus t dt in my q to p. Q to p. Because dt, dA is equal to minus dt, so I put minus dt. So we know minus of this becomes, if I can remove minus by changing the limits. So this becomes p to q, p plus q minus t dt. So in place of t dt, I can use any variable because limits are same, rest is same. The first formula, f of a dA, first formula is f of a dA or f of b dB, all are same. So I can use t, in place of t, I can use a dA. So I get integral pq, the f of a dA is p to q f of P plus Q minus A dA. Because f of t dt can be written as f of A dA. F of t dt can be written as f of A dA. The first fundamental using the property 1. Any rest are all same. Limits are same because I am not changing the limits here. I am putting t is a f of A t. So it is the same. With these things will simplify my definite integrals. Simplify my definite integrals. It can be put as f of b db, just f of b db, f of c dc. Anything can be put. In place of c dc, I am putting f of a itself. No problem when the limits are same. So both equations are same. Let us see the next property. These two are same. In place of 0 to p, I am adding both limits here. 0 plus p is p. So no problem. Now let us say 0 to 2p is this is the formula. So 0 to 2p can be written as 0 to p plus p to 2p. 0 to p can be written as 0 to p plus p to 2p. P to 2p. Let's see property 6. Integral 0 to 2p f of a ds 0 to p. This we have to prove. We know this can be written as this. We can separate. This is a property 3. They can be added. Areas can be added continuously in two different areas. So 0 to 2p can be distributed as 0 to p and p to 2. 0 to p and p to 2p. Okay. Let us say this is I1. This is I2. So let us take 0 to 2p I2. I am putting a, let t is equal to 2p minus a, or a is equal to 2p minus t. So dA is equal to minus dt. Minus dt. When a is equal to p, when a is equal to p, t is also p. When a is equal to 2p, t is 0. So when I substitute in I2, so p in place of p, I am putting a, I am putting t dt, f of 2p minus t dt. Minus is come in place of d, dA, I am putting dt minus dt. So for t, it becomes 3 to 0. So this minus goes, I'll get 0 to p. So 0 to p, f of 2p minus t dt. So that is why 0 to 2p is equal to f of 0 to p f of a dA plus 0 to p f of 2p minus a dA. So 0 to 2p can be written as 0 to p and 0 p to 2p. So when I'm using a is equal to 2p minus t and dA is equal to minus dt, and limits are changing, p to 2p becoming p to 0. So this minus gets converted, it becomes 0 to p f of 2p minus t dt. So this I2, again I1 plus I2. So 0 to p f of a dA plus 0 to p f of 2p minus a dA. Now let us see here. From the using earlier formula, this formula, a plus b, p plus q minus a. F of a dA is p plus q minus a dA. Using this formula, what is this becoming? This becoming 0 to 2p f of 2p minus a dA. Both are equal. 0 to 2p f of 2p minus a dA. So it can be written as 0 to p f of 2p minus a dA plus p to 2p f of 2p minus a dA. That also possible. So we can use 2p together. So 2p minus a f 0 to p and p to 2p f of 2p minus a. Or we can use first split, then used here p to 2p. This automatically becomes 3p minus a dA. This is automatically becoming P2 2P 3P minus A dA, because I can add these two, P2 2P 3P minus A dA. But further I have to simplify into 0 to P format. So if I simplify to 0 to P format, then I'm getting 2P minus A by this substitution. So you can write it 0 to P f of A dA plus 0 to P f of 2P minus A dA, or this can be written as plus P to 2P f of 2P minus A dA, or P to 2P f of 3P minus A dA. Like that, we can use both the formulas. So now let us see our property 7. 0 to 2P f of A dA is equal to 2 into 0 to P f of A dA will go here. Property 7. 0 to 2. 0 to 2P f of A dA, this minus not there, is equal to 2 into 0 to P f of A dA if f of 2P minus A is what f of A. If f of 2P minus A is minus f of A, then it is 0. Simple. This we know 0 to 2P is the combination of these two. If this is minus of f of A, this is 0. If it is same of f of A, it's 2 into 0 to P f of A. So this we are first converting into property 6 format. 2P minus A, 0 to P. But if it is minus f of A, if it is say 3P minus A, let us say f of 3P minus A. F of 3P minus A is f of A, because we know 0 to 2P will become 0 to P and P to 2P. P to 2P, if I add 3P minus A, is equal to f of A. But is f of 2P minus A f of A? We do not know. It can be f of A, it can be minus f of A, it can be something else. So this, if it is an even function, f of 2P minus A is f of A, then it is 2 into 0 to P. Both are same. This is also same. This is also same. Minus P2 plus P. Minus P2 plus P. It can be written as minus P2 0 plus 0 to P. Minus P2 0 plus 0 to P. So in place of 0 to P, I am getting f of minus A. 0 to P, this 2P becomes 0. F of minus A is f of A. Then I get 2 into f of minus A. F of minus A, if it is minus f of A, I am getting 0. This is nothing but same. You see here, this is an even function. This is an even function. Minus A to plus A. This is my minus A to 0 is also f of A, is positive. 0 to plus A is also positive. So I'm getting areas are equal. So 2 into 0 to A, f of A dA. If they are negative, if minus A, f of minus A is minus of f of A, they get cancelled out. They get cancelled out and becomes 0. So this is the application, this is the drawing for this formula. This formula has come from derivation. From this formula, this has come. If 2P minus A is f of A, I'm getting 2 into f of A. If 2P minus A is minus f of A, I'm getting 0. If it is an even function, f of A is minus f of A, I'm getting this. So both are positive. 2P minus A is f of A, also I'm getting 0. If it is odd function, also I'm getting 0. F of A is f of A, I'm getting even function. So we have to see what possibilities I can simplify. This is the way. So let us see minus P to P. Minus P to P can be written as minus P to 0 and 0 to P. So here, in place of A, I am using minus A. This can be, it can be put as minus. If I put T is minus A, dt is minus dt. So this becomes 0 to P because minus f of A. So it becomes minus 0 to P f of minus A dA. F of minus A dA. So when we add 2 into f of A dA, if it is f of minus A is equal to f of A. If f of minus a is not equal to f of a, this becomes 0. This is becoming 0 because f of minus a is minus f of a. In that case, this becomes 0. Nothing but same in the pictorial form. This is f of a is minus f of minus a. This is f of minus a is f of a. Minus a means what? X is plus a, y is plus, x is minus a, y is also plus. So f of minus a is also plus, f of a is also plus. Here in this case, x is plus a, y is plus, x is minus a, y is minus. So f of a is equal to minus of f of minus. So in both cases, the addition is, here is 0, here is 2 times. 2 times the half limit. I need not do total limit, I can do half the limit. Suppose it is given 0 to pi. So I can make it as 0 to 2 into 0 to pi by 2. Like that. Let us say another function, another property. f of x dx is limits 0 to nt, where t is the time period. Let us say sine, it is like a sine theta. Here period of function is around 2 pi. Every 2 pi sine repeats. So a number of 2 pi's, I can simply add the areas. So 0 to t plus t to 2t plus 2t to 3t, all areas are same because the same time period. So n into 0 to t fx dx. By physical understanding, we can do this. Or we can substitute. Let us say k minus 1t to kt. Let us put x as t minus kt. So dx is equal to dt. Dx is equal to dt. So when I substitute this, I am getting 0 to t fx dx. Same. K minus 1t to kt is equal to 0 to t fx. I am getting same value, but it is understanding when time period is there. It is not varying. Up to time period, it is equals of time period. Like sine theta, cos theta, all based on time period. So I can simply multiply n times. Okay. Let us do some examples on properties of integration. Let us see this. Integral sine cubed x by sine cubed x plus cos cubed x dx limits 0 to pi by 2. In earlier, if the limits are not there, we have to use some other method. Either we have to take sine is 2t by 1 minus t square, cos is 1 minus t square by 1 plus t square. We have to do all such calculation. Since 0 to pi by 2 is there, we know a plus b minus p plus q minus a is also same. So if I use that formula, so what is 0 plus pi by 2? Pi by 2. So this becomes sine cubed pi by 2 minus x, that is cos cubed x. So this also becomes cos cubed x plus sine cubed x. So when I add these two, 2a is equal to 1 integral dx. 2a is equal to these two getting cancelled out. So my answer is integral x is pi by 2. I put the limit. So pi by 4 is the, when 2 comes here, out of the 2a, 2 comes here, a is pi by 4. See, so simple. We're using these properties. These properties are helpful to us in solving a difficult limit integrals. Okay, let us see this. X by sin x plus cos x dx. Normally we do this here. T is tan x by 2, something like that. We do it now because limits are given 0 to pi by 2. So I am substituting pi by 2 minus. In place of x, I am putting pi by 2 minus x. So this becomes pi by 2 sin x plus cos x minus x by sin cos x plus sin x. This is nothing but here. X by sin x plus cos x is here. So this goes here, 2a. This goes to here, 2a, and comes as 1, 2 comes here, pi by 4 integral dx by sin x plus cos x. Now this is normal derivation. Even if I put pi by 2 minus x, it won't change. It won't change. So I'm using general formula. Use tan x by 2 to convert sine and cos into same variable. So t is tan x by 2. Sin x is equal to 2t by 1 plus t square. Cos x is equal to 1 minus t square by 1 plus t square. And dx is equal to 1 plus t square dt. 2 into 1 plus t square dt. So limit is 0, x is 0, t is 0, and x is pi by 2, t is 1. When we substitute, what I am getting? Pi by 4, 2 dt by a square minus t square. This is the form of dx by a square minus x square. A square minus x square, that is log of x plus a by x minus a minus x. A plus x by a. These are partial fractions. A plus x into a minus x. I can write it as a by a plus x plus b by a minus x. When I do partial fractions, this is the formula we have done earlier of a 1 by 2a into log of a plus x by a minus x. This is the formula we have done integrals. We are using for definite integrals. Earlier we have done normal integrals. So when we use this, pi by 4 into 1 by 2a, 1 by 2a, 2 dt, 2 is there, 2 is there. So 2a is 2 root 2 log x plus a by a plus x by a minus x. A is what? A is 2. So when we have simplified dx by sin x plus cos x in terms of t, what finally I am getting? Pi by 4 integral 2 dt by 2t plus 1 minus t square. This is the form we got. So 2 comes out of this becomes pi by 2. So pi by 2 dt by 2t plus 1 minus t square. This 2t plus 1 minus t square can be written as a square minus t minus 1 whole square. This can be written as 2 minus t minus 1 whole square. So this will, so pi by 4 into 2 dt by a square minus t minus 1 whole t square. A square is root 2. A is root 2. So we know this formula, log of a plus x by a minus x 1 by 2a. So I am substituting this formula. So pi by 4 into 2 by 2 into a root 2 into log of a plus x. A is root 2. X is t minus 1 by a minus x. Limits 0 to 1. When I am substituting 0 to 1, what I am getting? Pi by 4 root 2 log of root 2 plus 1 by root 2 minus 1. If I do conjugate method, I multiply root 2 plus 1 both sides. This becomes a square minus b square. This is 1. So this is root 2 plus 1 whole square. So this square will come here. The square will come here. This becomes pi by 2 root 2 log root 2 plus 1. Because in logarithm, the square will come to n log n. Log x to the power of n is n log n. So the 2 is coming here, reducing this. Okay. Let us do another problem. Limit of root of a square minus x square dx. This we have just seen. The formula derivation x by 2 square root of a square minus x square plus a square by 2 sin inverse x by a. This is the formula. So I have to put minus a2 plus a. Is this an even function? Yes. In place of x, if I put minus a, what is happening? The f of x is not changing. Plus a or minus 8 is same. So this is equal to 2 into 0 to a. 2 into 0 to a. So 2 into 0 to a. So if I am substituting the first terms, it becomes 0. X is 0. So when a is when putting x is here, this term is becoming 0. When I'm putting x is 0, this term. So first term is becoming 0. So second term is a square by 2 sin inverse 0 by a 0. 0 means 0. Sin inverse a 1 means pi by 2. So pi by 2 into a square. Pi by 2 into a square. So this 2 into 0 to a, this 2 and 2 getting cancelled. This 2 and 2 getting cancelled. So pi by 2 a square. Even if I put minus a to a in place of 0 to a, if I put minus a to a, then what will happen? Then also we'll get same answer. Then also we'll get same answer. Let us put here the second term. A square by 2 into sine inverse minus a. First I put plus a. Sine inverse 1. This is pi by 2 minus half. Sine inverse minus 1 is minus pi by 2. So 2 times plus pi by 2. So in place of 2 into 1 time pi by 2, I am getting pi by 2 plus pi by 2. So 2 times pi by 2. So this by 2 get cancelled. So it becomes pi a square by 2. Okay, we can put minus a to a. I need not use this formula also, because here automatically it gets added up. I need not, here you see here, when you do minus a to a, it automatically gets added up. I need not do 2 into 0 to a, I need not do. If it is minus, it automatically gets 0. Minus a to a, it is better to put minus a to a. It will take care even or odd. I need not put any formula. I can go directly minus a to a. I will use 0 to a when I am getting some advantage. I can use other formulas if I put 0 to a. Let us see. Integral dx by 1 plus sin x. If I put 0 to pi, so the sine of pi minus x is what? Sin x. That means sine of pi minus x is sin x. So the given expression becomes 2 into dx by 1 plus sin x limits 0 to pi by 2. Because let us derive the same formula here. Let it be split into two limits, 0 to pi by 2 and pi by 2 to pi. So here t is pi minus x. dt becomes minus dx. So when x is pi by 2, t becomes pi by 2. When x is pi, t becomes 0. So when you substitute these changes, putting minus integral dt by 1 minus sin pi minus t limits pi by 2 to 0. I can change the minus. So this becomes integral dt by 1 plus sin t limits 0 to pi by 2. So dt by sin t I can written as dA dx by sin x. So dx by sin x 0 to pi by 2. That means 2 into 0 to pi by 2 dx by sin x. So this is where we can do this. Or if I simply say that if of sine of pi minus x is sin x, I can use this formula. This, suppose if I put simply p plus q minus a dA, that formula. So 0 to pi, so pi dx by 1 plus sine of pi minus x is equal to sin x. So there's no use of changing to that, using that property. So we have to use other property. So that is, even sine of pi minus x is sin x. I'm getting 2 into pi 0 to limits 0 to pi by 2, 2 into dx 1 plus sin x. Why I am going for pi by 2? Because in what form I can convert this? I can convert this. I cannot get 2 cos 2x or any cos 2x. I need sin square x by x. I'm not having this. So I cannot do cos 2x here, convert into cos 2x. So I'm going to 0 to pi by 2. This is how, this is a derivation of pi by 2. So 2 into 0 to pi by 2. If I put now substitute pi by 2 minus x, this is 1 by 1 plus cos x. 1 plus cos x can be written as 2 cos squared x by 2 minus 1. So 1 getting cancelled, 2 cos squared x by 2. 2 getting cancelled. So integral secant square x by 2 nothing but tan x by 2 into 2. limits 0 to pi. When I put it 0 to pi by 2, I am getting 2 answer. So I have to convert it into a known form. This I can do. Cos x is 2 cos squared x by 2 minus 1. 1 getting cancelled. So it becomes 2 cos squared x by 2. Secant square x by 2 in the top. So tan x. But so the formula, to bring it to the usable formula, I am using the properties of the definite integrals. See another one. Now this is being asked from the fundamentals. This is from fundamentals. N to infinity, we have to add this. This is in the form of what? Limit n to infinity. I am taking 2 to the power of k out. I am taking 2 to the power of k out. Then what is becoming here? It is giving n to the power k plus 1 by n to the power of k plus 1. If n to the power of 1 I am taking out. So 2 to the power of k by n sigma, then what I get? I by n whole to the power of k. Because this is n to the power of k is left out everywhere. 1 n I have taken out. So everywhere n to the power of k is left out. So n to the power of k, 2 by k I have taken out. Here 1 is left out. 1 by n to the power of k plus 2 by n to the power of k plus. So k is varying from, I is varying from 1 to n. So 1 by n to the power of k, 2 by n to the power of k, 3 by n to the power of k, like that, n by 2, n by n to the power of k. So 2 I have taken out here. 2 to the power of k has been taken to the left out is n to the power of k. So this whole expression can be written in this form. This is nothing but integration. So 2 to the power of k sigma 1 by n sigma I by n k is equal to integral x to the power of k dA. X to the power of k, the I by n is x. In place of x I replaced with I by n. Earlier this is the expansion form we have understood. Is the expansion form. Wherever x is there, I have used is I by n. So 1 by n, 2 by n, this is x. Similarly, here x by k. So integral x by k dx is nothing but x by k plus x to the power of k plus 1 by k plus 1. So when I use, right, answer is 2 to the power of k by k plus 1. So I have to convert this sum of series into a integrable form. Let us see another example. Limit of n tends to infinity, 1 plus 1 by n into 1 plus 2 by n, like that, 1 plus n by n whole to the power of 1 by n. Whole to the power of 1 by n. Let it be p. So I have taken log p. Log p is 1 by n log of this. So now let us calculate 1 by n log of this. So this is 1 by n, limit of 1 by n log of 1 plus x. This becomes I by n, 1 by n, 2 by n, 3 by n, n by n. This I by n, as I tends to 1 to n, n is infinity. So this is in the form of log of 1 plus x. Limits to 0 to 1. Because only 1 n is there. Only 1 up to n by n. If it is 4n by n, it becomes 4. If it is 3n by n, it becomes 3. So this is n by n. So this is limit is 1. So this is the integration. So when I do integration, so integration of log of 1 plus x dx. Here integration is there. So integration of log of 1 plus x dx. So I will use UV formula, x log of 1 plus dx minus integral x into 1 by 1 plus x. So this in place of x, I can use 1 plus x minus 1. So I can split into 1 by 1 plus x is log of 1 plus x. Integral x is x. Integral dx is equal to x. So now I am substituting limits 0 to 1. 0 to I am getting log 4 minus 1, which is nothing but log of p. This is not answer. Answer is p is log of p. So log of p is equal to log 4. 1 can be written as log e. 4 by e. 4 by e. So p is equal to 4 by e. This is the answer. So whenever such expansions are given to the power of 1 by n, so I can convert it into logarithmic. So this is a logarithmic function. Log of 1 plus I by n. See, what is here? Log a, b, c, d is equal to log a, log b plus log c plus log d plus log. That formula is used. Here it is multiplication. When it comes to logarithmic, it can be used as sigma. This is summation. So this is nothing but my fundamentals of integration of function. Okay. Let us continue chapter 7b. We will start with chapter 7b. Okay. 7b is section 1. There are 3-4 sections in this. So to understand the definite integrals with the limits, let us understand this chapter. Fourth question. 1, 2, 3 are simple. Let us do fourth one. Integral sine cubed x cos cubed x dx. The limits 0 to pi. So as we know the rules, 0 plus pi minus x also will give the same a. So sine cubed pi minus x into cos cubed pi minus x dx. So sine pi minus x is sine x. So cos pi minus x is minus cos x. Minus cos x whole cubed is minus cos cubed x. So this is also a. So when we add 2a, this becomes 0. A plus a is 2a. This becomes 0. That means a is 0. This is using the formula. Suppose I want to do rough. Sin cubed x cos cubed x dx 0 to pi is a. So I put as cos cubed as 1 minus sin squared x. So sin cubed x, here cos x is there. Cos x, cos square is this, cos x is there. So sin cubed x cos x minus sin to the power of 5x cos x. This is nothing but sin to the power of 4 by 4 and sin to the power of 6 by 6. When I apply 0 to pi, sin theta 0 to pi is 0. So entire is 0. So I can do a normal method, or by using formula, it is easy for me. Okay. Integral mod of 1 minus x dx limits 0 to 2. If you see, draw the equation. What is mod of 1 minus x? X minus x square by 2 integration. So if I draw the curve, this is from 0, at half it is 3.8, at 1 it is 0, at 1.5 it is minus 3.8, at 2 it is 0. If we add without mod, these two get cancelled. These two get cancelled out and become 0. Since mod is given, that means what I have to do? I have to split into 2, 0 to 1 and 1 to 2. So 0 to 1 will be plus, 1 to 2 also mod, it will become plus. So this is f of minus x is f of x because it is same. So we will put is 2 into x minus x square by 2 limits 0 to 1. So answer is 1. So you understand the difference between mod and no mod. We'll see one more example of mod and no mod here. This is mod of 2 minus x. Mod of 2 minus x dx. What is integration? 2x minus x square by 2. If I substitute 0 and 4, 2 into 4 is 8 minus 16 x square by 2 is again 8. This is x square by 2. This is 8 minus 8. 0. So this is becoming 0, 0. So both, if I put mod 2 into mod of 2 minus x, the limits 0 to 2. And then I am getting 2 into 2, 4. So, but actually what is happening? Area between 0 to 2 is equal to area between 2 to 4. But they are on the other side of the axis, x-axis. So mod is adding them. Otherwise they get cancelled out as shown in the limits. The same time. Okay, let us see another example. Integral cos x by 1 plus e to the power of x dx. Limits minus pi by 2 plus pi by 2. When I add these two, it will become 0. So p plus q is 0. I put a cos of minus x is cos x by 1 plus e to the power of minus x. E to the power of minus x is 1 by e to the power of x. That means e to the power of x plus 1 into by e to the power of x will come into the numerator. So this is the equation. So I am adding 1 and subtracting 1. So then what it becomes? Or I am adding these two. Adding a plus a. 2a is equal to cos x into e to the power of x plus 1 by e to the power of x plus 1. These two get cancelled. So this becomes sin x. Sin x, when I put minus pi by 2 plus pi by 2, it becomes 2. So answer is 2a is 2, a is 1. So always remember, whenever we write such 2a, this 2 should go immediately to the right hand side in the next step. Otherwise, these two, at the end of the answer, we forget this 2a. So make it a practice, take it immediately to the other side. Only keep a on the left hand side. Okay, we'll see the other problem. Integral secant to the power of 4a dA. Limits 0 to pi by 2 is I. Secant to the power of 4, that means that even function. So I can put as 2 into 0 to pi by 4. 2 into 0 to pi by 4. So secant to the power of 4 can be written as secant square into secant square. Secant square is 1 plus tan square. So when I do, secant square is tan a, secant square a, tan square a is tan cubed a by 3. You have 3 tan square a into secant square a. So tan cubed a by 3. So when I substitute 0 to pi by 4, I am getting 8 by 3 as the answer. Okay, also same type. So f of x is f of minus x. This is even function. This is not this type. Even 1 to 2 also it is positive. 1 to 2 also it is positive. Pi by 2 to pi by 4 to pi by 2 also this is positive because it's an even function. Let us go to section 2. So exercise 7b, section 2. Integral x square by 1 plus x dx limits 0 to 4. So this is not an even function. Even if I do 0 plus 4, 4 minus x also, it's not going to add anything to me. So I'm going to simplify this. So this x square minus 1 plus 1. So x plus 1 into x minus 1 plus 1 by 3. This is log of 1 plus x. This becomes x plus 1 get cancelled, x minus 1. So x square by 2 minus x plus log of 1 plus x. You substitute the limits. So I'm getting 4 plus log 5. So here I am not using any formula because it is of no use using any property of the. So I have to simply solve the integral. Now here you see x square by x square plus 2 minus 1 to 2 minus 1 to 2. So this I have to add plus 2 and subtract minus 2. Add 2 and subtract minus 2. X square plus 2 by x square plus 2 is 1 and 2 by x square plus 2. This is the form of a square plus x square. So tan inverse x by a, 1 by a, tan inverse x by a is root 2. So 1 by root 2, tan inverse x by root 2. This one. This one becomes x. So when I substitute the limits of minus 1 to 2, here there is nothing of even or odd function. X square, because this is not evenly distributed, minus 1 to 2. So I am not going for distribution. Even though even function, I am not splitting this. So when I substitute, I am getting 2 into minus of minus 1 is plus 1. 3 minus root 2 into tan inverse root 2 minus tan inverse minus 1 by root 2. further. So we don't have a reading for tan inverse root 2. We have a reading for tan inverse 1 or sin inverse 1 by root 2 or cos inverse 1 by root 2, but tan inverse, we keep it answer like that. Let us see the third problem. Integral x square sin x dx. So it is simply UV formula. I am applying UV formula. And I put it, so I am integrating sin x minus cos x and differentiating x square 2x. Again here I am integrating cos x sin x and differentiating sin x. So I am converting it to this. When I apply my limits, I am getting answer as y minus 2. Okay. This is simple integration. So normally here I am not using any formula. I have simply done integration as per earlier chapter and applied the limits. This we have already done. Let us see this. Integral of sin square x minus cos square x by sin cubed x plus cos cubed x dx. It appears as if it is a difficult problem, but since 0 to pi by 2, so 0 plus pi by 2 is pi by 2. So I put pi by 2 minus x in place of x. So sin square pi by 2 minus x becomes cos square x. Cos square x. Cos square pi by 2 minus x becomes sin square x. Right? My sin cubed x, cos cubed x. Pi by 2 is always plus, pi by 2 minus is always plus. So when I first I have separated sin square x by this minus cos square x by this. When I absent cos square x by this minus sin square x. When I add these two, both are getting cancelled out. 0 is coming. So answer is 0. So by using whenever pi by 2 is there, we should be able to use the formula property. Problem number 8. Problem number 8. Limit of root of n plus 1 plus root of n plus 2 plus root of n plus 3 plus root of n plus n whole divided by n root n as n tends to infinity. Now whole divided by n I am taking first out. Root n I am converting to all sum. So root of sigma root of 1 by n I have taken out. Root of n plus 1 by root of n. So when I divide, n by n becomes 1, 1 by n. So root of 1 plus 1 by n, root of 1 plus 2 by n, root of 1 plus 3 by n, root of 1 plus n by n. So this is nothing but root of 1 plus I by n, I is equal to 1 to n. So this is my integration form, integral root of integration of root of 1 plus x as limits 0 to np. P is 1 here, so 0 to 1. So root of 1 plus x dx, I know 1 plus x whole to the power 3 by 2 by 3 by 2. When I apply 0 to 1, I am getting the answer. 2 by 3 into 2 to the power 3 by 2 minus 1. So we have to see from the fundamentals this infinite sum. Okay. Now similarly, 1 by n limit of 1 by n plus 1 plus 1 by n plus 2 plus 1 by 6n as n tends to infinity. Now again, I have to take 1n outside for my fundamental integration conversion. So 1 by n, if I take 1n outside, so what is this? I am taking out n and multiplying with n. So n by n plus 1, n by n plus 2, n by 6. So this n is brought to the denominator. 1 by 1 plus 1 by n, because 1 by n by n is 1. 1 plus 2 by n, so 6n can be written as n plus 5n. So 1 plus 5n by n. One plus 5n by n. So this is up to limited 5. 0 to 5. Log of 1 by 1 plus x. Limit of 1 by integration of 1 by 1. Wherever I by n is there, we have to put x. Wherever I by n is there, we have to put x. So I by n is where what? 1 by 1 plus I by n. So 1 by 1 plus x dx. This is log 1 plus x. So log 6. How 0 to 5? Here it is 6n. But I need in this form, everything I need 1 by I by n, 1 plus 2 by n. I need in this form. So I put n plus 5n. So 1 plus 5n by n. So this is a very typical problem, very important problem. Unless you do practice, we cannot get such ideas. But anyway, finally what I want 1 by n. I want in the form of sigma I by n. Something I by n. So this is what I create. Now, limit of 1 by n, tan. Here you see 1 by n is already given to me. Tan pi by 4 into 1 by n, pi by 4 into 2 by n, pi by 4 into 3 by n, pi by 4 into n by n. It's simply integration of tan pi by 4 x. Integration of tan pi by 4 x dx, limits 0 to 1. 0, n by n is 1. So tan p is 1. So what is tan? Log minus log cos pi x by 4 by pi by 4. Because 1 by cos into sine. So we can get tan. So plus minus has to be taken care. So when I substitute 0 to 1, I'm getting minus 4 by pi log 1 by root 2. 1 by root 2 is minus, if it goes out, it comes to root 2. Root comes out by 2. So 2 by pi log 2. By simplifying this, 2 by pi log 2. Let us see another problem. Limit of I cubed by I to the power 4 plus n to the power 4. I want in the name of I by n. What I want finally, sigma I by n. So I am taking out n to the power 4 out here. So this becomes I by 4 by n by 4 plus 1. So I got I by 4 by n by 4 here. But here I cubed by n by 4. So 1 n is taken out. So I cubed by n cubed, I by 4 by n by 4 plus 1. This is the sigma as n tends to infinity. So this is x cubed by x to the power 4 plus 1. Sigma x cubed by x to the power 4 plus 1. So nothing but log of 1 plus x to the power 4 by 4. Because 1 by x to the power 4, 4x cubed by 4. So this is the derivative of this. So when I put apply 0 to 1, I'm getting half 1 by 4 log 2. Let us see another problem. 1 plus 1 by n square into 1 plus 2 by 2 to the power of 2 by n square, 1 plus n to the power of 2 by n square whole to the power of 1 by n. So 1 by n square plus 1 by into 1 plus 2 by 2 square by n square, 1 plus n square by n square whole to the power of 1 by n. Whenever such whole to the power of 1 by n is given, we have to use logarithmic function. So log p is equal to 1 by n log of this. This multiplication will convert into summation. Because of log ABC is log A plus log B plus log C. Now this is in the form of what? 1 plus I by n square. 1 plus I square by n square. 2 square, 1, let it be 1 square. 1 plus 1 square by n square, 2 square by n square, n square by n square. So I square by n square, that is nothing but x square. So log of 1 plus x square dx. Limits is 0 to 1 because it is n square by n square. This is not 4n square or 5n square, this is n square by. So 0 to 1 is the limit. So this is we have to solve this. Let us do by UV method. X log 1 plus x square minus integral x by 1 plus x square into 2x. So 2x square. So I put 2x square plus 1 minus 1. So by convert 1 plus x square, I bring 1 plus x square and minus 1. So I'm getting this is nothing but tan inverse x. 1 by 1 plus tan square. Here 1 plus square getting cancelled. So integral dx is x. So when I'm substituting limits 0 to 1, I'm getting answer of log 2 minus 2 plus 2 pi by 4. That is equal to log p. So bring all logs together. Log p by 2 is equal to pi minus 4 by 2. So that means p is equal to 2 into e to the power of pi minus 4 by 2. So I'm taking out log here. 2 into e to the power of pi minus 4 by 2. So e goes e to the power of pi minus 4 by 2. So 2 goes here, 2 into. So we should remember we have taken log here. So wherever to the power is given 1 by n. So this is in the form of sigma I by n. 1 by n sigma I by n as n tends to infinity. So by fundamental log of 1 plus x square is my function. Students, let us do some more critical problems of discrete integrals. Let us see 7b section 3. Slightly difficult problems of discrete integral. Let us see. Integral dx by 4 plus 5 cos x limits 0 to pi by 2. Suppose if I use pi by 2 minus x, this becomes sin x. 4 plus 5 sin x. But I am not having any output from using the property. So let us go by fundamental. T is whenever such sin x, cos x are there, we use t is tan x by 2. So cos x is, we know, 1 minus t square by 1 plus t square. And what is dt is secant square x by 2 into dx into 1 by 2. Secant square is 1 plus tan square x by 2, so 1 plus t square. This is the standard we use in our integrals whenever sin theta, cos theta are given. So this becomes integral 2 dt by 1 plus t square. 2 dt by 1 plus t square is dx. See what is dx? 2 dt by 1 plus t square. Divided by 4 plus 5 cos x is 1 minus t square by 1 plus t square. When we simplify it, we get in the form of integral 2 dt by 9 minus t square. In the form of a square minus x square, dt by a square minus x square, so log a plus x by a minus x. So 2 into log of a plus x by a minus x, 1 by 2a. 1 by 2 into what is a is? A square, this is 3 square. So a is 3, so 1 by 2a. So log 3 plus t by 3 minus t. What are the limits? For the t limits, as x is 0, tan x by 2 is 0, so t is 0. As x is pi by 2, tan x by 2 is pi by 4, that is 1. So when I use 1, this becomes t plus 1. 1 plus 1, 2, log 2, 1 minus 1, t is 1. So this is not okay. Now log 0. So log 1 is 0, is also 0. So 1 by 3 log 2 is my answer. See here, log 3 plus t by 3 minus t, put t is 1. Upper limit is 1. So 3 plus 1, 4 by 3 minus 1, 2. So it becomes log 2. This is directly becoming log 2 minus, when put lower limit 0, 3 plus 0, 0 by 3, log 1. Log 1 is automatically 0. So that is why this log 1 is 0. So 1 by 3, log 2 is the answer. Okay. Now this, let us understand this one more difficult problem. Integral root of x minus a into b minus x dx limits a to b. Can I use any? Suppose a plus b minus x. If I use a plus b minus x, it becomes b minus x. This becomes a x minus a. The same thing is getting repeated. So no property is getting used here. So let us do in a rough method. Root, I am expanding this. When I am expanding a into b minus ab, x into minus x square. So minus a into minus x is plus ax, plus b into x is plus bx. So minus a into minus plus a plus b into x plus a plus b into x. When I'm taking a minus outside, so this minus x square become plus x square minus x into a plus bx. Now I'm converting it to a full square. A square minus 2ab plus b square. B square is a plus b by 2. B square is a plus b by b is a plus b by 2. B square is a plus b whole square by 4. I am adding and subtracting. So here I am subtracting in this, and here I am adding. A plus b whole square by 4 minus ab minus half x minus a plus b whole square by a plus b by 2 whole square. So this goes to minus 4ab. So this is nothing but a minus b whole square by a minus b whole square by 4. A minus b by 2 whole square. So this is the form of square root of a square minus x square. This is the form of a square minus x square. We know the formula for integral root of a square minus x square. X by 2 square root of a square minus x square plus a square by 2 sine inverse x by a. So I put x by 2 square root of a square minus x square. The whole under root will come. Root of a square minus x square plus x by 2. What is x here? This whole fraction is x. X minus x by 2 plus a square by 2. Here it comes a square by 2. A square is this what? A minus b by 2 whole square by 2. That means a minus b whole square by 8 it is coming by 8. Sine inverse x by a. This whole portion is x. This is a. So when I apply limits a to b, this whole root of a square minus x square is nothing but original format. This is only converted to this format. So instead of root of a square minus x square, I am putting x minus a into b minus x. Plus the second term as is, it is written. A minus b whole square by 8 sine inverse x by a. So when I apply a to b, here it becomes 0. When x is here, this is 0. When x is b, this is 0. So upper limit to lower limit, this first term is becoming 0. Now second term becomes a minus b whole square by 8 into 2. This is nothing but 2 sine inverse a minus b by a minus b. Because when I put a here, 2a minus a minus b. So a minus b. When I put b here, 2b minus a minus b. So b minus a. Sine inverse b minus a is minus of sine inverse a minus b. So that is why it is 2 times. Getting upper limit and lower limit getting added. It becomes 2 sine inverse a minus b by a. This is getting cancelled. This is pi by 2. So pi by 2 into 2 getting cancelled. So pi by 8 into a minus b whole square is the answer. You know how we got this 2 sine inverse? When I put x is a, 2a, this becomes a minus b by a minus b. When I put x is b, this becomes b minus a by a, sine inverse minus 1. So this is minus pi by 2. This is plus pi by 2. So minus of minus pi by 2 is plus pi by 2. So this becomes 2 into pi by 2. 2 into pi by 2, that is becoming pi by pi. So pi by 8, a minus b. Either we can do independently or we can club also. A very difficult problem to understand. So we have used the formula root of a square minus x square is equal to. So this given formula we are converted into this format. Okay. Now let us see the third problem. X sine inverse x by square root of 1 minus x square dx limits 0 to half. So we know sine inverse x derivation is root of 1 minus x square. 1 by root square root of 1 minus x square. So I am putting sine inverse x as t. When I put sine inverse x as t, so when I do dt is equal to dx by. So when I put sine inverse x as t, so when I do differentiate, what is the differential of sine inverse x? 1 by square root of 1 minus square dx is equal to dt. So automatically by dx by square root of 1 minus x square, this is becoming dt portion. This is x is equal to sine t. X is equal to sine t. Sine inverse x is equal to t. So what I am getting in the integration? X is equal to sine t. So the given expression becoming integral t sine t dt limits from 0 to pi by 6. Because when x is 0, sine inverse 0 is t is 0. When x is 1 by 2, sine inverse 1 by 2 is pi by 6, 30 degree. So we know this is a UV formula. So I am doing differentiation of sin t is minus cos t, t minus integral cos t into differentiation of t is dt. So this is nothing but sin t. Integral cos t is sin t. So sin t minus t cos t. Applying the limits 0 to pi by 6, I am getting 1 by 2 into 1 minus root 3 by 6 into pi. Because the cos 30 is root 3 by 2. What is cos 30? Root 3 by 2. Sin 30 half. Okay. So by seeing itself, since it is dx by square root of 1 minus x square and this is sin inverse x, I can use the substitution accordingly. It is simplifying my equation. But here no formula we have used, we have just done normal integration. Well, let us see this one. Sin x plus cos x into, this is into division, 9 plus 16 sin 2x dx, limit 0 to pi by 4. 0 to pi by 4. So there I cannot use a pi by 4 minus x, will not going to simplify my equation. So I am assuming sin x minus cos x is equal to t. Why sin x minus cos x is equal to t? What is d sin? What I do differentiation? Sin x becomes cos x, minus cos x becomes plus sin x dx. So this sin x plus cos x into dx will become my dt. So when I am squaring both sides, sin square x plus cos square x minus sin 2x. So I am getting here sin 2x is equal to 1 minus t square. So here sin 2x is 1 minus t square. So now I am substituting dt by 9 plus 16 into 1 minus t square. This is in the form of dt by a square minus x square. A square minus x square. So this is nothing but log of a plus x by a minus x by 4. Because the x, the multiplication is 40. So divided by 4. 1 by 2a. 1 by 2 into a is 5 here. So 1 by 2a log of a plus x by a minus x. Right? The whatever multiplication of x we are writing. So when I apply this limits of minus 1 and 0. See when x is 0. So sin 0 0, cos 0 1. So t is minus 1. When x is pi by 4. Sin pi by 4 1 by root 2 minus cos 0. So it becomes 0. The limits are minus 1 to 0. Limits are minus 1 to 0. So when I first substitute first 0, so log 5, how much am I getting? 4 into 5 into 10, 1 by 40, log of 5 plus 4 into t, t is 0. So log 5 by 5, log 1 getting cancelled. Now I put minus 1, log 5 minus 4 by 5 plus 5. So this is becoming 0. Log 5 minus 4 by 5 plus 5. So minus. See, here first I have to apply 0 first. First top limit is 0, bottom limit is minus 1. That means this is minus 1 and this is plus. So when I apply 0, this is become log 1 goes to 0. When I apply minus 1, this is being 5 minus 4 by 5 plus 4. This is log 1 by 9. So minus of this becoming plus. So minus of log 1 by 9 becoming plus of log 9. Log 9 is 3 square. Log 9 is log 3 square. 2 comes here. So 1 by 20 log 3 is the answer. 1 by 20. Because this is plus. Because first 0 will be substituted here. So this becomes 0. This is coming this side. Minus 1 will be substituted. 5 minus 4 is 1. 5 plus 4 is 9. So 1 by 9 becoming, when it comes to top, this becomes plus. Okay. This is a very good problem for exercise. And this is also very tough problem. Let us see problem number 5. Integral a sin x plus b cos x divided by sin x plus cos x dx limits 0 to pi by 2. So now I am going to substitute pi by 2 minus x. Because 0 plus pi by 2 is pi by 2. So sin pi by 2 minus x is cos x. Cos pi by 2 minus x is sin x. This becomes cos x. This becomes sin x. Okay. Sin x will become cos x will become sin x. So the given expression became this one. So when I add this a plus a, what is I am getting? Sin x into a plus b, cos x into a plus b. So when I take a plus b out, it will become sin x plus cos x. So underline also sin x plus cos x. So these two sin x plus cos x gets cancelled out. So integral of a plus b dx. This is nothing but a plus b into x. So when I apply limits, pi by 2 into a plus b, it is equal to 2a. So when 2 comes here, a is equal to pi by 4 into a plus b. Okay. Immediately once I get 2a, immediately it should come here. The 2 should come here. 1 by 2. A is equal to, because we may forget bringing the 2 into the answer. Okay. Next one. Understood this? By using the properties of my this integration. So pi by 2 minus x, I am getting a plus b is going out. So numerator and denominator getting cancelled. A into sin x cos x plus b into sin x plus cos x. So I can take out sin x plus cos x out. So it becomes a plus b. Sin x plus cos x will get cancelled. Okay. Next one. Integral x into a minus x whole to the power of n dx. It is simply UV formula. I go for differentiation. This I go for integration. So a minus x whole to the power of n minus 1 by n minus 1 into minus 1 into minus 1. So x remains same. So plus integral, this integral into dx. X differentiation is dx. So this is nothing but a minus x whole to the power of n plus 2 by n plus 2 into minus 1. So this is from, so now I am substituting limits of 0 to a. So what I am getting finally 1 by n plus 1, this becomes 0 to a. When I substitute a, this is 0. When I substitute 0, because x is there, this is 0. The first term with both the limits becoming 0. So I am only left with second term. So this becomes 1 in by n plus 1 into n plus 2 to a to the power of n plus 2. Because when x is a, this is 0. So when x is 0, so minus of minus will get cancelled, lower limit. So I am getting answer. That is another problem. X root of 2 minus x, same way, repeat. So I am doing using the formula 0 2. I am adding 0 plus 2 is 2. So in place of x, I am putting 2 minus x, 2 minus 2 minus x. So this is converting into root of 2 minus x root x. X root of 2 minus x is becoming 2 minus x root of x. So I can separate it, 2 root x minus x root x. This is x to the power of 3 by 2, this is x to the power of half. So when I do integrate, this is x to the power of 3 by 2 by 3 by 2, this is x to the power of 5 by 2 by 5 by 2. So when I use the limits 0 to 2, I am getting root 2 into 16 by 50. Okay, this is simple. I have used the formula here. 0 to 2, I have used the formula here. So that it becomes simplified. Root I am getting single, outside I am getting double, so that I can expand. Here also we have used the formula. Here also we have used the formula. Okay. So this whole chapter is meant to how to use the formula and simplify our integration. Let us see. X sine cubed x dx, limits 0 to pi. Let us use pi minus x. So here, when I use pi minus x, this x is getting eliminated. You see here, pi minus x, sine cubed pi minus x dx. Sine pi minus x is sine x. So this becomes pi of sine cubed x dx minus x of sine cubed x dx. X of sine cubed is nothing but a itself. So this minus a coming to this side becoming 2a. So 2a is equal to pi sine cubed x dx. Here this is simple. Sine square x into sine x, 1 minus cos square x. So integral pi sine x minus pi cos square. So this is cos cubed by 3. This is minus cos x. Integration of sine x is minus cos x. Integration of cos square x sine x is cos cubed by 3. Cos cubed x by 3. when I differentiate 3 cos squared x into minus sin x. So this minus will go here. So when I apply limit 0 to pi, I am getting answer 2 pi by 3. So here you use the formula and we have simplified. Otherwise, sin cubed x can be converted into sin 3x formula. Sin 3x and 3 sin x. Sin 3x and 3 sin x. X is there. I have to do double integration. So it is easy to use this method. Now, let us go integral x by 1 plus sin x dx. Limit 0 to pi. Again, I have to eliminate this x. I am using pi minus x rule. So pi minus x by 1 plus sin x. So again, x goes to here. X by 1 plus sin x goes to here, 2 here. Integral pi by 1 plus sin x. This is standard terms we can use. I can use as a tan x by 2, or this is another way. I multiply both 1 minus sin x by 1 minus sin x. So this will be cos square x. So 1 by cos square x is secant square x. Sin x by cos square x is tan x secant x. So this is a tan x integration. This is secant x integration. So when I apply the limits, I am getting I is equal to pi. 2i is equal to 2 pi, I is equal to pi. So I have in by 1 plus sin x. Here also we have seen earlier problem by 1 plus cos 4 plus 5. If they are same, if it is 5 plus 5 cos x, then I can go for 5 minus 5 cos x into 5 minus 5 cos x. I can convert this. Since they are different, so this cannot be, could not be used there. Now we have used here the type of approach. Let us go to next. Let us say x sin cubed x by 1 plus cos square x dx. So first I want to eliminate x here. So I will use pi minus x. So pi minus x, sin cubed pi minus x by 1 plus cos square pi minus x. So sin pi minus x is sin x, and cos square pi minus x is also cos square x, because cos pi minus x minus cos x, but square is there, so cos square x. So same pi into this minus again x into sin cubed x 1 plus cos square x. This becomes again a. So this goes to here, becomes 2a. 2a is equal to integral pi sin cubed x by 1 plus cos square x. So now sin cubed x can be written as sin x into 1 minus cos square x. So when I put cos x is equal to t, this becomes 1 plus t square. This is 1 minus t square. This sin x dx is dt. So this becomes 1 minus t square by 1 plus t square dt plus or minus pi. So now if you see 1 by 1 plus t square, this becomes minus of minus 1 by 1 plus t square. So 1 minus t square I am writing as 1 plus t square plus 2. 1 plus t square I am adding 2, subtracting 2. So this minus is there. So 1 plus t square get cancelled. Integral pi dt. Then 2 by 1 plus t square is there. So 2 pi into 1 plus t square is tan inverse t. 2 pi 1 plus t square is tan inverse t. Integral pi dt is pi t. So this is tan inverse t. Tan inverse t when t is what? Limits 1 to minus 1. Limits are 1 to how the 1 to minus 1 have come? See, cos x is equal to t. Limits are 0 to pi. Cos 0 is 1. Cos pi is minus 1. So bottom limit is 1, top limit is minus 1. So when you do this, tan inverse t, tan inverse 1 is pi by 4, minus tan inverse 1 is pi by 4. So pi by 2 we are getting here, minus 2 pi. So pi by 2 into pi minus 2 is the answer. I'll repeat again. I have gone very fast here. Let us come back. See, we have eliminated x here by putting pi minus x. I got up to this 2a is equal to integral pi sin cubed x by 1 plus cos square x. Now, normal, I have to do integration. So sin cubed x is written as sin x into 1 minus cos square x. So this is 1 plus cos square x. This is 1 minus cos square x. So here also I am putting 1 plus cos square x under minus. So I am putting minus 1 plus 1. So 2 minus of 1 plus cos square x. These two are getting cancelled. So I have to convert cos x into t. So sin x cos x will become dt. So into 1 minus t square by 1 plus t square. So again this will 1 minus t square 2. 2 minus 1 minus t square. So minus of pi dt, and already minus is there because when I taken cos x is equal to t, minus sin x dx is dt. So minus has come. So finally I got this. So this is in terms of 1 by 1 plus t square tan inverse t. Whatever multiplication is left out, 1 by 1 plus t square tan inverse t, 2 by 1 plus t square. This is 2 by 1 plus t square, 2 into tan inverse t, and the rest is integral dt, that is dt. So this is a multiplication. Pi is the multiplication. Okay. So let us see this answer. Log of 1 plus x by 1 plus x whole square dx. Limits 0 to 1. So I know 1 plus tan square is equal to secant square. So I have taken that as a starting point. X is equal to tan y. So dx is equal to secant square by dy. So denominator is having secant square by, these two getting cancelled. So I have taken x is tan y. So now what is giving? Log of 1 plus tan y into secant square by dy by secant square y. These two are getting cancelled. So finally the equation is becoming log of 1 plus tan y. So tan y can be written as sin y by cos y. So cos y plus sin y by cos y. So log of a by b, log a minus log b. This is log a minus log b. Now this I can write as, suppose if we put root 2 multiplication division. So root 2 into sin y by root 2 plus cos y by root 2. So sin a, 1 by root 2 is cos sin 45. 1 by root 2 is cos 45. So sin a cos b plus cos a sin b. So sin of a plus b into root 2 minus log of cos y. So what are the limits here? Limits here, when x is 0 to 1, x is 0, tan y is 0, y is 0. When x is 1, this is pi by 4. So limits are pi by 4, 0 to pi by 4. So here again, log a plus log b, log a plus log root 2 dy. This is only numeral. So this comes y dy, log root 2 into y. So remove the integral. Here, since 0 to pi by 4, I am adding here pi by 4. In place of y, I am putting pi by 4 minus y. So what is being 45 plus 45? 90 minus y? Cos y. So log cos y minus of log cos y. These two are getting cancelled out. So I am getting log root 2 into y. Y is pi by 4. So answer is root 2. When I take out root 2, half will come here. Pi by 8 log 2. Okay. So it's very a typical problem involving normal integration plus applying my rule. So instead of log cos y, we do not know. We don't have any log cos y. We don't have any because these are getting cancelled. Let us see another one. Integral x sin x by 1 plus cos square x, 0 to pi. So again, if I use pi minus x, x gets eliminated. So pi minus x, sin pi minus 1 plus cos square pi minus x. So 2a is equal to pi sin x by 1 plus cos square x. So let's put cos x is equal to t. So the top one will become dt minus dt and 1 plus t square. Minus dt by 1 plus t square. This is tan inverse t. So minus pi into tan inverse t. If I am applying the limits 1 to minus 1, I am getting pi square by 4. Okay. Hello students. Let us continue our integrals. We will do some more problems from the chapter 7b section 3. Let us see this problem. Integral sin square x by sin x plus cos x dx, limits 0 to pi by 2. So when we use pi by 2 minus, then what will this become? Integral cos square x by sin x plus cos x. Cos square x by sin x plus cos x. So now it is easy. When we add these two, a plus a, sin square x plus cos square x will become 1. So 2a is equal to integral 1 by sin x plus cos x dx. We can do in different forms. We can put sin x as tan x by 2 as t, or we can convert everything into t form, or we can use whenever sin x plus cos x is given, I can convert into sin a cos b plus cos a sin b. So if I divide by root 2 and multiply by root 2, here I am dividing by root 2 and multiplying by root 2. This divide by root 2 will come to the, here multiplying root 2 will be denominator. So sin a cos 45 is 1 by root 2, cos a sin 45 is 1 by root 2. So this will become sin of a plus b, x plus 45. 1 by root 2 is outside. So this becomes cosecant. We know the integration of cosecant x minus log cosecant x plus cot x. This is minus log cosecant x plus cot x, limits 0 to pi by 2. When we apply 0 to pi by 2, what we are getting? Log of this is cosecant. So here x is pi by 2 upper limit. So cosecant pi by 2 plus x is secant pi by 4, because it is like sine 90 plus x is cos x. Similarly, cot 90 plus x is minus tan x, minus tan x. So this is the sine model is important here. So this is the upper limit. Now bottom limit is cosecant pi by 4 plus cot pi by 4. So when we substitute the values, what I am getting? 1 by root 2 log of root 2 plus 1 by root 2 minus 1. If I do conjugate multiplying, root 2 plus 1 whole square by 2 minus 1. So whole square comes to this side, 2 by root 2, that means root 2. Root 2 log root 2 plus 1 is the answer. This we have 2 here, 2a. So the 2a, 2 will come here. So 1 by root 2 log root 2 plus 1 is the final answer. What actually we have done in this problem? We have used pi by 2 minus x, so that the sin square x is eliminated. We have come to 2a. So now sin x plus cos x, different ways of handling it. Tan x by 2 is t, or we can use, whenever such combination is given, I can convert it into a single form. Sin a cos b plus cos a sin b. Okay, let us do this. 1 by 3 plus 2 cos x dx. Here I am using single x is cos x is there. Here both are there. So we have used sin a cos a sin b approach. But here single is there. So I am using tan x by 2 is t, cos x is 2t by 1 minus t square. Secant square x by 2 half dx is equal to dt. So when I am substituting here, in place of dt, 2 dt by 1 plus t square divided by 3 plus 2 into cos x is 1 minus t square by 1 plus t. Sin x is 2t by 1 plus t square. Cos x is 1 minus t square by 1 plus t. So finally I am getting 2 dt by 5 plus t. So this is tan inverse t by root 5. Tan inverse t by root 5. 1 by a tan inverse root by. This is 2 into 1 by a is root 5. Tan inverse t by root 5. When I apply the limits 0 to infinity. When I put x is 0, t is 0. When I put x is pi, what is tan pi by 2 is infinity. So I'm putting 0 to infinity. So automatically what I am getting 2 by root 5 pi by 2. Tan inverse, when t is 0, tan inverse 0 is 0 and tan inverse infinity is pi by 2. So pi by 2 I got total pi by root 5. See here, this is 3 plus 2 cos x. Here 3 is more, the cos x component is less. So totally we are getting 3 into 1 plus t square. So t square will be positive here. In earlier problem, we have seen here dx by 4 plus 5 cos x. Here 4 is less, 5 is more. So this is coming into a square minus t square form, because t square will be 4t square minus 5t square. So it is minus. So this we get log of a plus b by a minus b 1 by 2a. So by changing these coefficients, whether it will come to 1 by 2a log of a plus b by a minus b or tan inverse x by a, 1 by a tan inverse x by a. Here important is limits. Changing the limits from 0 to pi to 0 to infinity. When I put infinity here, this is pi by 2. So pi by 2 is cancelled, pi by root 5. Okay, let us see another problem. Integral log of 1 plus tan x dx. This is nothing but log 1 plus tan x is sin x plus cos x minus log cos x. So like again sin a cos b, cos a sin b, 1 by root 2 into root 2. So log root 2 plus log of sin a plus b minus log cos x. So log root 2 into pi by 4 is we have applied the limits plus integral log pi by 4 plus x can be written as 0 to pi by 4. So I am putting in place of x pi by 4 minus x. So then it becomes what? Pi by 2 minus x. This is cos x. So integral log plus log cos x minus log cos x getting cancelled. So I am getting this is the answer. Pi by 8 log 2. Because root comes out, half it will become pi by 8 log 2. See, this is the same problem. Integral log of sin x plus cos x we have seen earlier in this problem. When x is tan y, integral log of sin y plus cos y dy minus log of cos y. Same steps here. We have pi by 8 log 2 here also, and here also pi by 8 log 2. Okay, let us see that. Integral x sin pi x dx limits minus 1 to 3 by 2. What is integration of x sin pi x dx? When I do integration of sin pi x, it is cos pi x by y minus cos pi x by pi into x minus of integral differentiation of x is 1. This becomes minus cos pi x by pi. So what is the integration of minus cos pi? Sin pi x by pi square. So now I am applying limits here. So what I am getting? 1 by pi square plus 1 by pi. Both are plus. In fact, both are upper limit and lower limit are plus. So that is why the mod indicates it should come in the positive. They should not get cancelled out. Okay. Now let us see this. 17. Integral sin inverse 2x by 1 plus x square. You simply say 2x by 1 plus x square is limiting to a. This what is 2t by 1 plus t square is sin theta, sin x. 2t 2 tan x by 2 by 1 plus tan square x by 2 is sin theta. So we can use that here when x is equal to tan y by 2. So this whole thing becomes sin y. So sin inverse sin y is equal to y. So when absolute dx is equal to 2x by 1 plus x square is equal to sin y. Tan y by 2. So from which sin y is equal to 2t by 1 plus t square and dx is equal to secant square y by 2 half dy. So when I substitute here sin inverse sin y into half dx is equal to secant square y by 2 dy. Okay, now it is converted into a simple secant square x. Secant square x is y by 2 tan y by 2. So I am putting uv formula. What is integration of secant square? Tan y by 2 by 2. So y by 2. So sin inverse sin y becoming y by 2 by 2. Secant square y by 2. So when I integrate it, y by 2 into tan y by 2 by y by 2 by 1 by 2 means into 2. So the first minus integral of tan y by 2 into dy. So you know tan y by 2 integration is log of cos y minus of log cos y by 2 into 2. Because when I differentiate log cos y by 2, 1 by cos y by 2 into minus sin y by 2 into 1 by 2. So to compensate that, we use minus will go to plus and 2 will be there. So my total answer is, when I substitute my limits, what are the limits now? When I use x is equal to tan y by 2, when x is 0, y is 0. When x is pi by 2, when x is pi by 2, oh sorry, 0 to 1. X is 0 to 1. So when x is 0, 1, tan is pi by 2. So that tan pi by 4 is 1. So y is pi by 2. So when I substitute those limits, I'm getting pi by 2 minus log 2. Okay. So what is that we have proceeded here in this problem? We have seen sine inverse sine y. 2t by 1 plus t square is sine y. So when x is tan x by 2, tan y by 2. So 2 tan y by 2 by 1 plus tan square y by 2 is sine y. This is what we have simplified this equation. Let us see another problem. Integral x tan inverse x dx, limits 0 to 1. So x tan inverse x dx. Let tan inverse x is equal to y. So tan y is equal to x. Secant square y dy is equal to dx. Limits 0 to 1 becomes 0 to pi by 4. So when I substitute here, in place of x, I'm using tan y. In place of tan inverse x, I'm using y. In place of dx, we are using secant square y dy. So this is becoming y into, what is integration of tan y secant square y? Tan square y by 2. Tan square y by 2, when do differentiate, 2 tan y into secant square y. So this is used in tan y integration. Minus half of tan y. This, we have tan square y into differentiation of y is dy. So integral tan square y, I can put it as secant square y minus 1. So this is tan y minus y. So when I apply my limits of 0 to pi by 4, I'm getting pi by 4 minus 1 by 2. Very precise problem and a lot of intricacies. See, so how I have proceeded here? I have to combine these two, tan inverse x and x, I have to combine. So we have to combine x and tan inverse x. So when I put tan inverse x is y, so tan y is equal to x. So I would combine both into single form. Okay, now let us see. X sin x by 1 plus cos square x dx, limits 0 to pi. So now I have to remove x here. So I am using pi minus x. So pi minus x then becomes 2a, becomes integral pi sin x by 1 plus cos square x. So this is nothing but, if I, this is 1 plus x square, 1 by 1 plus x square is tan inverse x. So tan inverse cos x. What is cos x differentiation? Sin x. Sin x is there supporting. So I have finally minus pi tan inverse cos x. How we got it? If I put cos x as t, this becomes minus dt by 1 plus t square. So dt by 1 plus t square is tan inverse t. So tan inverse cos x. Minus will be there. So when I apply the limits, here what are the limits here? What are the limits? 0 to pi. So when cos pi is minus 1, when I put it, cos pi is minus 1. Tan inverse minus 1 is minus pi by 4. Tan inverse plus 1 is pi by 4. So minus of minus will cancel. This becomes pi by 2, pi square by 2. So 2a is pi square by 2. A is pi square by 4. See, we are always forgetting here. Immediately these two should come here. Otherwise, this step we have already forgotten. So this, whenever 2a comes, whenever I am removing x in the equation, minus a, when a comes here, automatically put 1 by 2 here. They're more safe. Otherwise, our answer will be up to this point. This we are normally, generally we forget this. Okay, let us do some other type of problems. Now, using this integrals, definite integrals for reduction problems. What is integral sin to the power of nx? We have seen in the integration sin to the power of nx is minus 1 by n sine to the power of n minus 1x cos x plus n minus 1 by n integral sine to the power of n minus 2x dx. Now you see here, if I put 0 to pi by 2, when I put pi by 2, cos pi by 2 is 0. When I put 0, sine 0 is 0. So this first term is getting 0 when the limits are 0 to pi by 2. So what is left out in this with the limits? It is left out is n minus 1 by n integral I n minus 2. So each time when I use n minus 1 by n, then next comes n minus 2 minus 1 by n minus 2 into I n minus 4. So by each time the power is reduced by 2 times. Each time the power is reduced by 2 times. So when if it is even, the last power will be 0. So integral dx 0 to pi by 2 will become pi by 2. Will become pi by 2. If the last term is odd, then in the last term will be every time 2 times the power is reducing. So integral sin x dx will become cos x will become 1. When I apply limits, it is 1. So always remember, when I am getting 1 by 2 in the expansion of sine to the power of x in the last, it will be pi by 2. I am getting 2 by 3, it is 1. Always remember, 1 by 2 is pi by 2, 2 by 3 I am getting, it is, here it is getting 1 by 2, pi by 2. Wherever you get 2 by 3, it is into 1, because that is even odd. Even odd. So when I n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4, finally I am getting 1 by 2 means what? N is even. If n is even, so this is odd, n minus 1, n minus 3, n minus 5, n minus 7 odd, so I am getting 1 by 2. Last term, last multiplication, that means pi by 2 is the balance integration. Okay, let us go for the examples. Suppose integral cos to the power of 7x is there. 7 is odd, so odd, so 7 minus 1 by 7, 7 minus 3, 7 minus 1 is 6 by 7 into 5 by 4 by 5. This is becoming E 4 by 7 minus 3. 7 minus 5, 2 by 3. So here we are, ultimately we got 2 by 3. 2 by 3 means this is, I am getting integral cos x, that is 1. Integral sin x is left out. The integration is cos x, that is 1. So this is odd function. This is odd. So I am getting n minus 1 by n, 6 by 7. Every time you reduce by 2, 2, 2. 6 by 7. Each power is reduced by 2. 6 by 7, 4 by 5, 2 by 3. So last term is 2 by 3. So into 1. So this is the answer. Suppose here given an even term. So 9 by 10, 7 by 8, 5 by 6, 3 by 4, 1 by 2. Since last term is 1 by 2, of course this is even. So I am getting pi by 2 is the integral dx. Because each time power is reduced by 2. When I do 9 by 10 into I n minus 2, sine to the power of 8x, 7 by 8 into I n minus 2, to the power of 6x, 5 by 6 into I n minus 2, to the power of 4x, 1 by 2 I minus 2, 2x or 0. So 10 means here one this means 8, 6, 8, 6, 4, 2, 0. So integral sine 0, sine to the power of 0 means integral dx. That is, when I apply limits, it is pi by 2. Okay, so the answer is 315 by 2560 pi. Let us see another type of reduction formula. Sine to the power of mx cos to the power of nx. So you have given nx and mx, but it normally sine to the power of mx cos to the power of nx. So this is the formula. Now we do it in generalized. When I apply 0 to pi by 2, this term is getting 0. So when I say Imn, m means sine to the power of mx. Here it is sine to the power of nx, but in the formula is I sine to the power of mx cos to the power of nx is equal to, we know this one. So this is cos to the power of m here, but I am taking n. So n minus 1 by m plus n, I m into n minus 2. This is n minus 2. Okay. So just the formula is reverse here. the powers are taken reverse, but I am applying for general purpose. So n minus 1, n is the power of cos. So n minus 1 by m plus n into I m. Sine power remains same. It becomes each time when I do this multiplication, the cos power is reduced by 2. Again, same thing. If cos is odd, so in last I am getting integral cos x. Last I am getting sine to the power of mx cos integral cos x. So I can do it sine to the power of m plus 1 by m plus 1. When I apply it 0 to pi by 2, it becomes simply 1 by m plus 1. So when n is odd, I'm getting 1 by m plus 1 last term. If n is even, what is the last? This will become 0, cos to the power of 0x. So integral sine to the power of mx. Sine to the power of mx, we have seen how to deal with this. It is integral sine to the power of mx. We have dealt here. Whether it is even, odd, the same terms will come. Here, sine powers will be reduced. Always remember, each multiplication, what 2 powers are reduced. If it is cos, initially cos will multiply, then we'll go for sine multiplication. Then we'll get, suppose here you see, first I am doing cos multiplication. N minus 1 by m plus n. So I am left out with cos n minus, cos to the power of n minus 2. Then n minus 3 by m plus n minus 2. Because left out power is n minus 2. So m plus n minus 2. N minus 5 m plus n. So in the last, if it is 1 by m plus 1, if n is odd. Because n is odd means what? We have a supportive cos x for sine to the power of mx. So it is 1 by m plus 1. If n is even, then I have again 2 options. Last term will be 1 by m plus 2. Last term will be m by m plus 2. Now m will start. Cos integral sine to the power of mx rules will solve. M minus 1 by m minus 3 by m minus 1. Like that will go if it is half pi by 2. If it is 2 by 3, it will be 1. So continuous multiplication will reduce both cos and sine powers in the integration. Let us do some examples. Sine to the power of 6x, cos to the power of 4x, dx. Limits, you have to understand, limits is 0 to pi by 2. If limit is 0 to pi, then this is not 0. So this term also will be added. Since it is 0 to pi by 2, only the first term is getting 0. So this multiplication factor scenario only appears when limits are 0 to pi by 2. Okay, now let us see. Here we know. So 4 minus 1 by m plus n is 10. 4 minus 3 by m plus n minus 2. Again, it will reduce by 2 to 2 each. First one is 3 by 10. If I reduce 2, it will become 1 by 8. 8 itself is m plus 2. See, last one is 1 by m plus 2. So 6 plus 2 is 8. So here cos is even. This is even. So now all here cos squared x is left out. Here cos to the power of 0x is left out. So I have left out with integral sine to the power of 6x. This is also even. 6 is also even. So now I am using n minus 1 by m. So 5 by 6, 3 by 4, 1 by 2. Whenever last term 1 by 2, I have to get multiplication of pi by 2, integral dx. So 3 times the power are reduced, sine to the power of 4x, sine square x, sine to the power of 0x. So integral dx becomes pi by 2. So this is a continuation. This is first cos x is reduced, then sine to the power is reduced. So I have multiplied 3 pi by 500. Now here you see, sine is even, cos is odd. When cos is odd, let us proceed. I will not get like this. If cos is odd, this becomes 0. If this becomes cos x, 1 by 1 plus 1 will come. Let us see. So 5 minus 1 by m plus n, 6 plus 5, 11. Into this is become 4 by 11, then 2 by 9. 9 is what? M plus 2. 2 by 9. M plus 1. Here if n is odd, it is 1 by m plus 1. So Here you see here 5 plus 1 by m plus n is 11, 6 plus 5 is 11. So 4 by 11, 4 minus 2, 2 by 11 minus 2, 9. Or we can say m plus n minus 2. So 2 by 9. 2 powers are reduced for the cos. So cos becomes integral cos x. So sin 2 of 6x cos x is sin 2 of 7x by 7. So that is 1 by m plus 1. Is 1 by m plus 1 in place of sin integration. This m plus 1 is sin integration. So m plus n minus 2. Like that it goes on reducing till cos power becomes 1. So because it is odd. So here simply I got 1 by m plus n. I need not go for, because sin to the power of 6x cos x is 1 by m plus n. So now see third example. Both are sin is odd, cos is even. So when I reduce 2 times, my cos will become 0 power. So 3 by 9, 9 is how come? 5 plus 4, m plus n. 3 by 9 into 1 by 7. So now integral sin to the power of 5x. So 4 by 5 into 2 by 3. Whenever 2 by 3 comes, it is into 1. Integral sin x is 1. Sin x is reduced by each time 2 powers. So sin 2 squared, sin. Integral sin x is 1, 0 to pi by 2. So this is the answer. Let us do another. Integral x sin to the power of 7x cos to the power of 6x dx limits 0 to pi. You see, imagine this is 0 to pi. So I want to eliminate first x. So I will use pi minus x formula. So pi minus x, pi minus x, pi minus x. So pi minus x is pi into this. Sin to the power of pi minus x is sin x. Cos to the power of pi minus x is minus cos x. But whole to the power of 6, this is an even power. So this becomes plus something. So minus, the remaining term is again the same term, a. So 2a is equal to pi integral sin to the power of 7x cos x. Cos to the power of 6x. We have the power now. We can do this. But it is 0 to pi. So if it is f of x is f of minus x, let us see. Is f of x f of minus x? Here, see, f of x is not minus f of minus x, because when I put sin of minus x, it is minus sin x. So whole to the power of 7 will be minus, cos to the power of 6 it will be plus. But this is minus x. But here what formula we are using? Here we are interpreting, let us see this formula. No, see this formula. F of 2p minus a. F of 2p minus a. This formula. 0 to 2p. Here we have 0 to pi. So 0 to pi by 2, pi by 2 to pi. So when we use this 0 to 2p, 2 into 0p f of a dA, if f of 2p minus a is equal to f of a. F of 2p minus a is equal to f of a. So if it is f of 2p minus a is minus f of a, then it will be 0. So property 7. Let us see the property 7 here. In place of 2p, we have pi here. Suppose pi here. So sin of pi minus x is sin x. Now cos of pi minus x is minus cos x. Whole to the power of 6. This is an even power. So this is also plus. So here f of 2p minus x is equal to f of x. So that is the formula here we have used. F of 2p minus x is equal to f of x. So So pi is there. So when we use the property 7 here, f of 2p minus x is f of x. Let us see pi minus x, the whole term sine is positive. Pi minus x cos is negative, but whole to the power of 6 this also becoming positive. So f of 2p minus x is f of x. So I can use here 0 to pi by 2 into 2. So 2 into pi is already there earlier. 0 to pi by 2 sine to the power of 7x. Now I can apply the formula. So 6 cos to 6 reduction is 6 minus 1 by m plus 1. 7 plus 6 is 13. So 5 by 13, 3 by 11 into 1 by integral sine to the power of 7x dx. Here sine reduction of sine to the power of mx is equal to n minus 1 by m, n minus 1 by m, n minus 3 by m minus 2. So finally I got 2 by 3. When I get 2 by 3, it is into 1. So the total multiplication is 16 pi by 3003. So here we have used this formula. F of minus x, f of x is not f of minus x here, but f of 2p minus x is f of x. 2p is 0 to 2p, initial one. Here in place of 2p is p, pi. Here p is pi by 2. Okay, go to next problem. Integral sine cubed x cos to the power of 6x dx limits 0 to pi. Same here, 0 to pi. So this can be written as sine cubed x can be written as sin x into 1 minus cos square x. So sin x cos to square 1 into cos to the power of 6x minus sin x cos to the power of 8. This is simply supported by, here cos is supported by sin, here also supported by sin. Cos to the power of 7x by 7, cos to the power of 9x by 9. So it will become minus, it will become plus. So when I apply 0 to pi, so I need not go for 0 to pi by 2. I need not do that action here. I can simply split it. Otherwise, I am supposed to use 2 into 0 to pi by 2 and sine to the power of mx cos to the power of nx. But I can do straight away with a, since power is less, I can do straight. Here also the power is less. Integral sine square x cos to the power of 4x dx 0 to 2 pi. Since it's an even function, sine square and cos to the power of 4, so it can be 2 into 0 to pi. Further, it's an even function, it can be 4 into 0 to pi by 2. So I know this one. So cos of 4 is 4 minus 1 by m plus n, 6. 3 by 6 into 1 by 4. So the 2 are reduced here. Integral sine square x is 1 by 2. Whenever 1 by 2 is there, we get pi by 2. So when I multiply, I am getting pi by 8. So I have used here f of x is equal to f of minus x function. Property number 8. Okay, now we'll go to another problem. Integral sine square is cos 7x minus pi by 2 to plus pi by 2. Here it is given minus pi by 2 to plus pi by 2. So here f of x is equal to f of minus x. Because minus pi by 2 is an even function. Cos of minus pi by plus by 2 is odd. This is minus, and to the power also is cos of minus x. Here you see, if I put pi by 2 minus x, pi by 2 minus x, both are positive. Pi by 2 plus x, this is negative. This is positive. But if I put in place of x minus x, so sine square minus x is minus sine x whole square. This is also positive. Cos to the power of minus x, cos minus x is cos x, this is also positive. So here I am using property number 8. F of x will f of minus x. So 2 into 0 to pi by 2. 2 into 0 to pi by 2. Now I can apply the reduction formula. So 7 becomes 6 by 9 into 4 by 7 into 2 by 5. 3 times it is reduced. Now cos x is remained. So 1 by m plus n. It becomes 1 by 3. So 32 by 315. So let's see another problem. Integral sine cubed x cos cubed x dx limit pi by minus pi by 2 to plus pi by 2. Here we know f of x is not equal to f of minus x because sine of minus x is minus sine x, cube is minus, so this becomes automatically 0. Here this becomes 0. Here 0 to 2p is not coming here, minus pi by 2 to plus pi by 2. This is 0 to pi, this is minus pi by 2 to plus pi by 2. Okay, f of x is not equal to f of minus x. So that means automatically what happens here, minus pi by 2 to 0 and 0 to pi by 2, these two areas are getting cancelled out. When x is on this side, x is on the other side, positive side and negative side, they are getting cancelled. We have seen earlier this type of example in the figure. Here is when f of x is minus of f of x, these two get cancelled. When f of x is plus of f of minus x, then the 2 into 0 to pi by 2 is sufficient. So there is a difference. So this is what we have done. Now we go to next problem. Integral x to a square minus x square whole to the power of 7 by 2 dx. Limits 0 to a. 0 to a. See here, I want to convert it into easy form. So if I put x is a sine theta, then I can get a square minus a square sine square theta. So a square cos square theta. So this will be simplified for me. But here you see, I cannot put x is sine theta because the limits are 0 to a. So x varies from 0 to a. If I put x is only sine theta, then my maximum limit of x is 1 plus r minus 1. It cannot go up to a. So it has to be a sine theta. Okay, now we simplified it. X is equal to a sine theta. This becomes a cos squared theta. So square root 1 by 2 get cancelled. A cos to the power of 7 theta. And this dx is equal to a cos theta d theta. So finally I am getting powers. Here simply cos to the power of 9 theta by 9 because sine is supporting cos minus is there. Cos of 9 theta by 9 minus is there. When I apply limits 0 to pi by 2, I am getting a to the power of 9 by, because first term pi by 2 getting 0, minus of it, actually it is minus. So a to the power of 9 by 9. Let us see another problem. So what I am doing it, finally I am converting it to integral sine theta of n theta, cos to the power of n theta. Similarly, x to the power of 5, 1 minus x whole to the power of 5 by 2 dx. So I want in terms of squares. So if I put x is sine theta, it's not solving my problem because under root is there. So I need x is sine square theta. So what is 2 sine theta cos theta is dx. Okay, when I substitute here, x to the power sine square to the power of 5 is sine to the power of 10 theta into cos square, square and half getting cancelled, cos to the power of 5 theta into 2 sine theta cos theta d theta. Theta is difficult, so I put a here. Okay, 2 into sine to the power of 11 because sine a and 10 to the power of 10 and 12 11 cos 2 in cos to the power of 5 into cos to the power of 6. Now it is our simple thing. So first we will reduce cos. This is 3 times cos will go up. So 5 by 6 plus 11, 17. 5 by 17, 3 by 15, 1 by 13. So now cos is reduced. Now integral sine to the power of 11 is left over. 2 is there before itself. So this again I have to reduce it. So n minus 1 by n. So 10 by 11. I'll go on reducing by 2. 8 by 9, 6 by 7, 4 by 2 by 3 has come. So that means it is 1. Multiplication is, that is integral sine theta d theta. That is integral 0 to pi by 2, it is 1. So this is the answer. So let us see another such problem. Same here x to the power of 5. This is x cubed 5x square whole to the power of 7 by 2. Here again I said x is limit is 0 to 5. So I have to take 5 sine theta. 5 sine theta. So same repeat problem. Same repeat problem. Here finally what I am getting? 5 to the power of 11 sine cubed theta cos 8 got to the power of 8 theta d theta. So I have to reduce first cos. 8 means even. So I'll all 4 times I have to reduce. So 7 by 11, 5 by 9, 3 by 1, 1 by 5. This is cos is reduced. Now I have left out with integral sine cubed theta. So here 2 by 3 into 1. So this is my answer. So let us see. Integral root of 7 minus x by root of x minus 3. Top there is 7 minus root 7 minus, bottom root x minus 3. Limits 3 to 7. So we know the first formula a plus b minus x can be replaced. So when I am replacing x with 10 minus x, here 10 minus x. Same thing is becoming root of x minus 3 by 7 minus x. Reverse. We're going reverse. When I'm doing addition, when I do my LCM, so I'll multiply these two. Root of x minus 3 to root of 7 minus x is this the answer. And the top one, I'm getting root 7 minus x plus x minus 3. So finally, what is this one? X is getting cancelled. 7 minus 3 is 4. So 2a is equal to integral. So 4, so 2 getting cancelled. 2 is left over here. 1 by root of a square minus x square format. I converted into square root of a square minus x square format. This is sine inverse x by a. Sine inverse x by a. And I substitute the limits. Substitute the limits. I'm getting the answer. Here, there is no reduction coming into picture. There is no reduction coming into picture. Only if I use this property, I can reduce it to a form of 1 by square root of a square minus x. Whenever in the denominator there is an x square, I have to convert it into either x square minus a square or a square minus x. Because x square there is minus here, so I am converting into a perfect square with addition of numeral. Minus 21. So I can go add 4 and minus 4. So 25, 25. So 4 is added, 4 is reduced. So it becomes minus 25. So that is 5 square. Okay. Now apply the limits I got to pi is the answer. So we have to mix the property as well as my earlier integration methods so that to simplify my work. Let us see. Integral of 6 minus x into x minus 2 dx limits 2 to 6. So simply I have to multiply this. Then I have to convert it to a square minus x square. This is x by 2 square root of a square minus x square plus a square by 2 sine inverse minus a by 2 sine inverse x root of a square minus x square. So sine inverse x by a square by 2. What is a square by 2? A square is 4. So 4 by 2 sine inverse x by a. Same problem we have seen earlier. 6 minus x into x minus 2 under root. We have seen a and b form here. This one. Root of x minus a into b minus x. In place of a, b is given some 2 and 6. But otherwise here limits a to b. Same problem. In place of a, b, the numerals are given. So what we have done here, we have converted into a square minus x square. A square minus x square, now we know x by 2 square root of a square minus x square plus a square by 2 sine inverse x by a. So same thing here. But here it is. This is plus. So x by 2 square root of a square minus x square plus a square by 2 sine inverse x by a limits 2 to 6. So when we apply the limits, First 6. 6 by 2, square root of 2 square, 4 minus 4. This becomes 0. 0 into anything is 0. This is plus 2 into sine inverse 2 by 2 is 1. So this is pi by 2. This becomes pi by 2. This is minus, I put apply 2 here. So here again 0. Minus 2 into, again the first term is become 0. Second time minus 2 into sine inverse minus 1. This is minus pi by 2. So minus pi by 2 to get cancelled, minus pi, pi minus of minus plus pi. So total 2 pi is coming here. This is 0. This is pi plus pi. This is wrong. What is this becoming? Where is my pi? Take it from here. Two into pi by 2 plus 2 into pi by 2. So this becomes 2. So this is plus here. So here plus will come. Sine inverse plus 1 is pi by 2. So 2 into pi by 2 is pi. Minus of sine inverse minus 1 is minus pi by 2. So minus into minus plus. So this is the answer. So this is the same time. Instead of a minus x into x minus b, we got two answers. A root of a square minus x square. So let us see another problem. Integral 1 plus cos x whole cubed. So I will simply expand this. A plus b whole cube. A cubed plus b cubed plus 3a square b plus 3ab square. So it is simple, my conversion. So this is integral x 0 to pi pi. Into cos cubed. Cos cubed I know how to reduce. Cos cubed theta is equal to sine cubed is n minus 1 by n 2 by 3. I know 2 by 3 is there. This is 2 by 3 into 0. Two by 3 means one time it is reduced. Integral cos x. Integral cos x over 0 to pi is 0. This is not pi by 2, remember. So this is pi. Integral. So integral 3 cos x is 3 sin x. 0 to pi sin x is 0. So here also last term sin x will come. Sin x integral sin x 0 to pi is 0. Then 3 cos squared x. This is 3 cos squared x can be written as cos 2x in terms of cos 2x, and we can solve this 3 by 2 pi. So when I add this 3 by 2 pi plus pi, I am getting 5 by 2 pi. This is a simple integration we can do ourselves. So then we have reduction formula. Cos x into cos square x. Cos square x can be written as 1 minus sin square x. So integral cos x. Integral cos x is 0. Just we have seen into 1 minus sin cubed x by 3. Also 0. Sin cubed sin x is also 0. These two terms are getting 0. Let us see other problem. Integral 1 plus cos x to the power of 5 into 1 minus cos x whole cube dx. Here I know I can put a plus b into a minus b to the power of 3. Then to the power of 2 is left out. So when I combine to the power of 3 here, so 1 minus cos squared to the power of 3 into what is left out is 1 plus cos x to the power of 2. So when I simplify this, I am getting x, this is a plus b whole square. So I am getting 3 terms. The integral sine to the power of 6x. This is 0 to 2 pi. So this is an even function. So 4 into 0 to pi by 2, sine to the power of 6x. This is also even function. and this is also 4 sine to the power 6x cos square x dx. This is limits 0 to pi by 2. This I can solve directly. Sine to the power 7 by 7 directly. This is limit 0 to 2. So last term is 0 because I apply 2 pi also 0, apply 0 also 0. So sine integral sine 0 to pi here also becoming 0. So left out is first two terms. So let us do my reduction. Integral sine 4 sin to 6 dx sin to 6x cos squared x. Cos squared x can be written as 1 minus sine square x. Here cos square x is reduced. So what I put m minus n minus 1 by m plus n. So 1 by 8. So this becomes 0. So in cos to the power of 0x. So what is left out is sine to the power of 6x. Here also sine to the power of 6x, sine to the power of 6x. So I can add these two. These two become 9 by 2. Sine to the power of 6x. 5 by 6, 3 by 4, 1 by 2 has come in the last. So I get integral dx. That is pi by 2. Because one time 4x is left out. Second time reduction 2x is left out. Third time reduction 0 is left out. So integral dx is pi by 2. So this is the answer. Okay. So we have to use all methods to make our work fast, easy, and time saving. In the competitive exam, time is important. We should immediately go to next problem. Hello students, and the last portion of this different integrals, we have to cover the areas, how the different integrals are used to find the areas of curves under the curves and areas above the curves. We'll see. Okay. Let us see different integrals for areas. Suppose this is a curve. This is the y is f of x. Between the limits from this point to this point, it has these gray areas are above area and red areas are below the area. If we have to add this integral from minus a to plus b, then how the integration behaves? It will add the positive areas and reduce the negative areas. It will take it as a vectoric sum. It will take it as a vectoric sum. Okay, vectoric sum. Here also same thing. Between a to b, area under the curve a to b, it can be a to c plus c to b. Area is, you can add in a parts also. So this is a vectoric sum. Now you see here, I want the areas between two curves. This is y of 1 of f of x, this is g of x. So what this will do? It will first add the area of this a to b and blue curve. This total area it will give, integral this dx, integral fx dx. Minus gs dx, what it will do? It will reduce this area. It will reduce this area between x-axis and this. So it will do minus of this, it will do minus of this, it will do minus of this. That means it will be added. So this is, earlier we have added this portion extra under which is not between the curves. So this is getting reduced by this curve. Here also we have added extra, is getting reduced by this curve. But here we are supposed to add, because earlier f of x is only above the x-axis. This is the thing we added up. So this is to be added. So this is minus of minus will become plus. Because this area is minus, this area is plus, this area is plus. So we can do directly f of x minus g of x dx, we will get this area. Okay. Now if you see this one, integral 0 to 10 f of x dx. This is a dampening vibration. It's reducing, the amplitude is getting reduced. So all the areas can be added. If it is integral from 0 to 10, what will happen? 6, 15, 3, all these will be added, this will be minus. If it is mod, then I have to say 0 to 1 plus mod of 1 to 4 plus mod of 4 to 6 plus mod of 6 to 9 plus mod of 6 to 8, 8 to 10. So all will be added. So there is a difference between mod and direct. Okay. Let us see this. Area under the sine and cos curve. So area can be divided between 0 to pi and pi to 2 pi. So integral sin x dx 0 to pi, integral minus sin x dx pi to 2 pi, because this is minus, pi is minus. So minus sin x dx. So when we add this, minus cos x plus cos x. So when I put 0 to pi here, minus of cos pi minus cos 0. Cos pi is minus 1, cos 0 is minus 2, minus 2 into 1, 2. Again cos x, pi to 2 pi plus cos x. So cos 2 pi is 1, minus cos pi is minus 1, 2. So this is mod. We are adding mod here. But otherwise, if we add directly, we get zeros as positive and negative area get cancelled. So what is the area covered by a sine curve between 0 to 2 pi? 0. Because they get cancelled. So mod of this total area. Okay, let us see this. Area bounded by both sine and cos together at intersecting points. So you know sine 45 is cos 45. So pi by 4 is one limit. Again, pi plus pi by 4 is another limit. Here, 90 plus pi by 4, sine, this is sine curve. This is pi plus pi by 4 plus 1 by root 2. But cos becomes minus 1 by root 2. So they are not same. But at pi plus pi by 4, they are same. Both are minus 1 by root 2. So between these two these are the limits. Pi by 4 to 5 pi by 4. I want area, this is the area. So sine 0 is 0. So this is sine curve. Cos 0 is 1. This is cos curve. So integral sine x minus cos x dx. So when I subtract, I'm getting 2 root 2 units. Okay. Let us say area between x square minus 5x and 4 minus 2x. So I'm simply 4 minus 2x minus x square plus 5x dx. Limits minus 1 to 4. How we got minus 1 to 4? So these are the points that they are intersecting points. We have to solve these two lines. See, 4x. We get, how do we got minus 1 to 4? When we solve these two, x value is minus 1 and 4. So x value at minus 1, they are intersecting. X value, if I put minus 1 here, 1 plus 5, 6. Here 4 plus 2, 6. Both are tallying. If I put 4 here, 16 minus 20 minus 4. 4 minus 8 minus 4. They are tallying. So these are the limits. So now this is 4x minus 2, this is plus 3x square by 2 minus x squared by 3. I am substituting the limits first 4, then minus 1. I am getting 125 by 6. This is the area. So let us understand for study purpose. I want to first find out the area of 4 minus 2x from minus 1 to 0. Minus 1 to 0. So this is 4x minus x square by 2. By 2 to get cancelled, 4x minus x square. So the area is 5. So the area between this straight line and this portion is 5, inclusive of star. This star I don't want, I have to reduce it. So I am using here. Minus 1 to 0, x square minus 5x. This is x cubed by 3 minus 5 square by 2. This is 17 by 6. So the star portion is 17 by 6. This total portion is 5. So total 5 minus 17 by 6, I am getting only this 2. Is excluded. Now you see this area. Now again from 0 to 4, 0 to 4, 0 to 2, we have this half BH. Again 0 to 2, we have this 2 to 4, we have minus half BH. They are getting cancelled out. This star and this plus is because this not to be included. This is the curve going. I want the area between this curve and this curve. This should not be included. So they are automatically getting cancelled, 0. So now again x square minus 4x between minus 1 to 0, between 0 to 4, 0 to 4 up to this point. So I got total area. Minus 56. These are total area is minus. So this is minus 56 by 3, including star. But this star is already minus by this. So when I have to add this minus 56 by 3 and this minus this net area. From the upper curve minus lower curve. I am getting 125 by 6, 125 by 6. So instead of doing this such cumbersome various process, we can simply do directly. Okay. Let us see another way. Y is cos x and y is 1 minus 2x by p. So directly cos x minus 1 plus 2x by pi. Limits are 0 to pi by 2. So you see here, if x is pi by 2, y is 0. Here x is pi by 2, y is 0. X is 0 also, y is 1. X is 0, y is 1. So these are two are the intersecting points of x. So basically we are solving this. We are solving this. So 0 to pi by 2. Suppose y cos x is equal to 1 minus 2x by 5. So x is 0, x pi by 2 are tallying the equation. So when I do integration, sin x minus x plus x square by 2, it's cancelled by pi. So when I substitute these limits, I am getting 1 minus pi by 4. Let us say another, y is equal to e to the power of x, y is equal to x. These are the two. So when x is 0, e to the power of 0 is 1. E to the power of 0 is 1. Either between 0 to 1. When x is 1, y is equal to 1. Either y is equal to e to the power of 1. When x is 0, this is 1, this is 0. So he has given limits. So between the limits, we have to find what is the area between them. So you simply minus it. And it's x square by 2. You substitute it is e minus 3 by 2. Okay. Now area enclosed by mod x plus mod y is equal to 1. So what values of x it is substituting? Suppose x is 0, y is equal to 1. It is tallying. When x is minus 1, y is equal to 0, then it's also tallying. X is plus 1, y is equal to 0. So x limits are minus 1 to plus 1. So what is y here? Y is equal to 1 minus x. So integral 1 minus x dx equal to x minus x square by 2 is limits between minus 1 to plus 1. So I substitute here plus 1, minus of minus 1. So both are getting added. That means area is 2. Suppose if I do individually, so mod x, x can be greater than 0, y can be greater than 0. So this portion. So x plus y is equal to 1. This is the line. So x can be greater than 0, y can be less than 0. X is greater than 0, y less than 0. This portion. So all these four curves are representing this equation. So what is the area bounded by all these four curves? This is 1, this is 1, so this is root 2, root 2, root 2, root 2. So this is the square of root 2 into root 2 is equal to 2. So we can understand this way, or we can understand from minus 1 to 1 limits of x. Minus 1 to 1 limits of x, I am doing 1 minus x dx. So when I put 1 minus 1 by 2, this is half. 1 minus 1 by 2 is half. Minus half, I am putting minus 1. Minus 1 minus of 1 by 2. This is become minus 3 by 2. So plus 3 by 2 plus half is 4 by 2. Okay. Let us see this. Y is x square, y is 2x. Find the area covered. What is the, when we solve this, what I am getting? Limits 0 to 2. When x is 0, they are tallying. When x is 2 is also they are tallying. So x square minus 2x, this is the minus for f of x minus g of x. So x squared by 3 minus x square. When I substitute the limits, I am getting 4 by 3. So what is this here? I have to find out the limits first by solving these two equations and solve the f of x minus g of x integral dx. So similarly, y is sin 2x, y is root 3 sin x. So here again, if I solve these things, when x is 0, both are y tallying. When x is pi by 6, this is sin pi by 3. This is sin, this is root 3 by 2. This is also root 3 by 2. They are tallying. So 0 to pi by 6. So when I am doing a sin 2x minus root 3 sin x, sin 2x is cos 2x by 2 minus cos 2x by 2 minus root 3 into sin x is cos x. So plus root 3 cos x. I substitute 0 to pi by 6. I am getting 7 minus 4 root 3 by 4. Write 1 by 4 into 7 minus 4. Another equation. Y square is 4x, x square is 4a. This is two parabolas. Y square is 4x, x square is 4y. They are opposite parabolas. One is y-axis parabola, one is x-axis parabola. What is area bounded? Now I am solving these two. They are tallying for 0, they are tallying for 4. 4 into 4, 16. X is 4. Here 4 4s are 16. They are tallying. So when I solve this, I do, what is y here? Y is 2 root x. Here y, x square by 2, square by 4. So 2 root x minus x square by 4. I can put mod here. I can put mod here so that any area can be positive. So when I solve this, what is the expression? 2 into x to the 3 by 2 by 3 by 2. This is x cubed by 12. So when I substitute 0 to 4, I'm getting 16 by 3 units. So let us say between log x and e. So what is the tallying here? When x is equal to e, this becomes 1. This becomes y is equal to 1. When x is equal to 1, y is equal to 0. So I don't have any x limits here, but I have y limits here. Y is equal to 1, y is equal to 0 is the intersect point between them. When x is equal to e, log e is equal to 1. When x is equal to 0, when x is equal to 1, e cannot be 1. Okay, I get y is 0. So into e to the power of y, what is this? X is equal to e to the power of y. Here x is equal to e. So the graph between these two is e to the power of y minus e dy. And the limits are 0 to 1. Y limits. Y limits are 0 to 1. So when I substitute x is equal to e, so this is a vertical line, x is equal to e going like this, 2.3 something, x is equal to e. Another line is y is equal to log x. They are intersecting at y is 0 and y is 1. So what is y is 0? This one, this point, and y is 1. At this point, this log x is getting intersected. So when I solve this, e to the power of y is e to the power of y, e is equal to ey. So when I substitute 0 to 1, I am getting 1 unit. Okay. Let us see. Section 3. Area between y square is equal to 12 into x plus 3, y square is equal to 20 into 5 minus 6. Now I have to solve these two. Both are y square. So I am solving. I am getting y plus or minus 60. But I am getting y is plus or minus 6 root 60. So these are the limits I am getting. So let us see. I am y square by 12. What is x here? I am solving for y here. I am solving for y here. What is y here? X is equal to y square by 12 minus 3. Here what is x here? X is equal to 5 minus y square by 20. So both x I am solving. So I got y plus r minus 60. So I will do equation with dy. Projecting on either you project on x area or you project on y area, the area between the curves is same. If it is a single curve, then projection of x area and projection of y area, areas will be different. But if this between two curves, either you project on x axis or project on y axis, the area bound is same. So since I have a limits of y axis, I am projecting on y axis. So here, what is x here? Y square by 12 minus 3 minus of 5 minus y square by 12 dy. So when you solve this, this is the equation between minus 60 to plus 60. If I substitute minus 60, this is also minus. This is also minus. So both minus will become plus. So that is why I put 2 into, I substitute plus root 60. So I'm getting 64 root 5 by 3. Okay. So here, instead of going for dx, I'm going for dy because I can easily have a y limits. Here, x square minus x minus 1 less than y, y is less than minus 1. So y, I am putting this here, I am solving these two equations. Instead of y, I am putting minus 1. So minus 1 comes here, this get cancelled. X square minus x is less than 0. That means x is less than 0 or x is less than 1. That means x is between 0 and 1. So this can be have 0, this can have 1. So limits are 0 to 1. So now I am solving it. X square minus x minus 1 minus half minus 1. These two getting cancelled. X cubed by 3 minus square by 2 is the integral. When I substitute 0 to 1, I am getting 1 by 6 units. Similarly, a circle is given and a parabola is given. They are intersecting. Well, what is the area intersected by parabola? Dividing the circle in two areas. So what are those two areas? So let us see. So simply we are solving this to get the 2 points. 2y plus y square is equal to 8. So we are solving y square plus 2y minus 8 is equal to 0. Here I got y is equal to 2 or 4. So when I put y is equal to 2, here 2 2s are 4, x is equal to plus or minus 2. When y is equal to 4, I am getting here minus 4 minus 8. This is a non-real number. So I am taking y is only 2 as a valid one. So my limits are plus or minus 2 on the x-axis. So now I'll put y is equal to 8 minus x square under root. Here y is equal to x square by 2. So this is like that. A square x square 8 minus x square minus x square by 2. So I can separate it to two integrals. Integral root of 8 minus x square dx minus integral x square by 2 dx. So this I am separating two parts. I'm separating two parts. So first part is first part becoming a root of 8 minus, this is root of a square minus x square. Root of a square minus x square. So x by 2 square root of a square minus x square plus a square by 2 sine inverse x by a. This is the integration of first part. And second part is x cubed by 3 into 2 6. X cubed by 6. Limits are minus 2 to plus 2. So when I am substituting minus 2 to plus 2, what I am getting? 4 by 3 plus 2 by. See here. So here what I have done is we have eliminated minus 4 result, because minus 4 do not have any x real component. So that's why I cannot take here y limits. 2 to minus 4 I cannot take and convert into equation dy. Y in the f of y dy, because y minus 4 do not have any x value. So I have to use plus or minus 2 of x limits. Okay, now we go to another problem. So this is the area. So what is the area left out? What is the area of circle? This is radius. R square is 8. So pi r square is 8 pi. Pi r square is 8 pi. So 8 pi minus this is 6 pi minus 4 by 3 is the other area. This is the area covered by a parabola. This is the balance area. Okay. So let us see the ellipse. What is the area of ellipse? We have to find out area of ellipse. So from the symmetry we can see bottom curve is top curve are same. So I can say 2 into minus a to plus a, the limits, I can take this curve x square y square plus y square by b square is equal to 1. So what is y here? Y is equal to b by a square root of a square minus x square. So this is again my formula. X by 2 square root of a square minus square plus a square by 2 sine inverse x by a, limits of minus a to plus. When I substitute limit of minus a to plus a, I am getting 2b by a into x by 2 is a plus a, I am putting a by 2 into 0 plus a square by 2 into pi by 2. Here also 0 minus pi by 2 minus into minus plus. So I am getting pi ab. But I am getting pi ab. This is the answer. If it is a circle, my a is equal to b. So this is pi a square or pi r square is the area of the circle. Okay. Now let us see. Problem number 8. Y is equal to sine pi x, y is equal to x square minus x, and x is equal to 2. You want the bounded area between 3 curves. If it is only between these 2 curves, this is y is equal to sine pi x, because y is equal to sine pi x. And this curve is x square minus x. This curve is x square minus x. So this is the area coming. If it is only asked between these 2 curves, but he is asking between 3 curves. This is x2. So the limit of 1 to 2, this minus this. So This is nothing but limit of 1 to 2 x square minus x minus, this is x square minus x, this is sin pi x, between 1 to 2 x square minus sin pi x dx. So basically x2 to 2 means he has given me one of the limit. So other limit I am getting from the intersecting point. So when we solve this 1 to 2, I am getting 2 by pi plus 5 by 6. So let us see. Prove that y square is equal to 4x. This is equal to y square is equal to 4x. Square is equal to 4x. I can get plus y, I can have minus y for the same x. Suppose x is 4. So y is equal to plus or minus 4. Or minus 4. This is the parabola. Second curve is x square is equal to 4y. So he wants us to prove that divide the area of a square x 0 to 4. 0, 4, 4, 4, 4 into 3 equal areas. Into 3 equal areas. So let us see what is the area between these two curves. So I have to put on x-axis 0 to 4 limits y square is equal to 4x minus y square is equal to x square is equal to 4y. So I have to do so integral x square by 4 limits 0 to 4. What is y in this square? X square by 4, 0 to 4, I am getting area A. So x cubed by 12, area A is 1 by 3 into 16. This area A is 1 by 3 into 16. Similarly, area between y square 4x and y axis, this one, this area, integral y square by 4 dy. Here I am projecting onto y axis. So area B, this is also 1/3 by 16. So when these two areas are 1/3 by 16, the left out portion is 1/3 by 16. Otherwise, what I have to do? I have to make this f of x minus g of x between limits 0 to 4. Also, I'll get 1/3 by 16. So 4 into 4, 16 is the total area. So when this area is 7 by 16, this area is 16, 16 by 3, this area is 16 by 3, automatically this is also 16 by 3. So we can use these different integrals for finding the areas. So depending on the mod we are asking, depending on the total we are asking, this will be either 0 or will be added. Okay. So with this, my definite integrals lecture will be over. And we have to do more and more practice, more and more books we have to study, and more practice we have to do so that you get acquaintance using all the properties. Thank you.